Good morning, ladies and germs. I'm going to be convolving some kernels today, and that should be exciting. I'm on my phone because I'm putting the link in the thing, because I still am too lazy to update Discord. That's what the problem is. But that's alright. We're all a bit lazy sometimes, you know. I just saw somebody in the Discord remove themselves from sudo. That's insane. Oh shit, I forgot to ping. Whoops, my bad. I'm stupid. I have the stupidity disease. Okay. I'm gonna get started in a sec here. I just need to do that. Okay. So yeah, monetized. We're monetized, which is crazy. Honestly, I was not expecting for us to get here. There's this button, engage with the audience. I can start a Q&A. I can start a members only live stream. Yeah, we're not gonna do that, but you know, it's cool. Yeah, we can start a poll. Oh shit, I can do a poll now? Dude, that's so sick. Windows XP is sick. There you go. That's the poll. Holy shit. That's crazy. Yo, what's up? What's up, trying to think? How you doing? I'm gonna be convolving some 3D kernels today. Just to show the class where we left off yesterday. We can try and compile here and see. This is where we left off yesterday. We multi-threaded the simulation step, and now we've got these veiny looking things, you know? And I think that that's pretty neat. It was very painful. You know, it was an 8-hour stream. And so, you know, I'm thinking we just chill out today. We just don't really... I think it's sick, though. So many things are happening. Sorry for not coming around. I mean, I haven't really been streaming. So, I've only, you know... Since I finished the chess engine, now I'm gonna stream more, because I couldn't really stream the chess engine because my computer sucked too much to do that. But now that we're back to doing like this retro 3D graphic stuff, I can stream that. Get ready for a job interview? That's awesome, dude. Are you excited about the job? Like, is it something that you really want to do? Is it programming also? Are they gonna ask you leak code questions also? Yeah, that's pretty funny. We do a 360 if we turn around. Yeah, we should probably clamp that. I mean, you know, that's for the future, right? So also something that I realized was, you know, the normals that we're doing, the reason why they're not very smooth, I was like wondering this. The reason why the normals aren't smooth is because we aren't clamping the central differences. So that also has to do with it. So whenever I exit out, it exits out really hard and then crashes because of the threads. So I have to do that. Junior C++, oh, that's sick. Sitting and watching a lot of lectures, yeah. I mean, that's awesome. Getting a C++ job in, you know, 2076 has to be pretty hard, huh? But, you know, it's good. I mean, I think as far as like C++, more low level stuff, like that's the shit that AI can't do, you know? I think that the first ones to go are going to be, you know, the JavaScript guys, you know? Especially in your country, yeah. But I think C++ is a language that's never going to die. You know, C++ is going to be a language that is going to be around forever. You know, like in terms of like its usefulness, it's kind of like the most important programming language, for sure. So yeah, let's try and fix that. I kind of just want to, when we exit, I'm trying to figure out where the exit symbol where we exit out. Handle key input gives us, I've escaped destroy window, calls destroy window, and then we break out. So I think we also need to wait for the other threads to finish. So I think we just literally like copy in the wait. The thing is, I don't know, the handles should be, is it here? The handles should be, yeah, it is here. The handles should be here. Yeah, so this is fine. We can just wait for multiple objects here just to make sure that they exit. We'd also like send like sigkill or whatever, but I don't know how to do that on Windows, so whatever. Yeah, okay, there we go. We no longer crash. That's sick. Monetization though. My channel is actually monetized now, which is crazy. I never thought that was going to actually happen because of all the copyrighted music that I've played on stream. I thought that honestly, when I got the notification that I could apply, I was like, okay, well, you know, whatever, you know. But then like immediately a day after, it was just, you know, an immediate yes. Like the language and hate it at the same time. You pay with your time. You have to implement so many things. That's exactly what I like about it. I mean, my whole argument is that like I like programming, so why would I, you know, have an excuse to not program? That's the way I see it. But then again, like, you know, I still use like STB, right, and CJSON, right? So there's some level of that, and then there's some level of, you know. I also looked up how do I implement round, because round is apparently not in C89 on Visual Studio 2008, like inside of the math header, and like it's literally not in this file. And I was looking up what the implementation looks like, and apparently it's just super like ridiculous if you don't just like quantize it, you know. But whatever. So I just quantized it because I was like, okay, never mind. I guess it's just more efficient to do all those bit operations on it, but whatever. Sometimes I just get stuck in the swamp. You start to implement a thing, but in order to do it, you have to know another thing and so on. Yeah. Yeah. But that's, I mean, what else are you going to do? Yeah, man, it's a waste of time. But what else, I mean, what else would you be doing with your life? You know, at least for me, it's like, I mean, this is just the whatever it is to do, man. You know, you got to do it. What's up, Akash? How are you doing? Okay, so to go back to what we were doing yesterday, to avoid the mem copying stuff, I also was like thinking about this, and then I was like, okay, so what if we don't block the thread? What if we don't block the thread here, and instead we just actually every thread just says when it's done, and then we do this instead of having this arbitrary number that is just basically how many iterations until we block the thread. Let's just never block the thread and then just wait until all the threads are done and implement it manually, because I don't think that there is a function that does that, but we can just do that. We could just have a we could have it per thread data, right? Like we already have TDs, right? And so every iteration, all we have to do is just check if all of the flags are true. So that's what I'm gonna do. I'm just gonna put it on TD, just booleans for checking if it's done, right? I was studying math. Can you tell me if calculus is 100% accurate or its best approximation? I'm not sure what you mean by that. Like calculus as a whole, if it's 100% accurate in terms of like integrals and stuff like this, or I mean Well, I mean, it depends what you're talking about, right? Like, if we're talking about like the algebra that goes into finding, doing the derivatives and doing the proofs, yeah, it's 100% accurate. But in terms of like the theory behind, you know, I think it is kind of an approximation. Like, I don't really, when it comes to like calculus, right, and beyond linear algebra, beyond all that, it does kind of become a bit theoretical. Like, sure, we have found like parts in nature that make sense for the these mathematical concepts, right? But it is kind of theoretical in a way. Like, our understanding of like space and black holes and stuff is all based on this theoretical sort of, taking the derivative and trying to figure out dimensional space with mathematics, right? So I mean, in my opinion, it is a bit theoretical, but it's nonetheless, proven to exist to some extent, for sure. I have to finish the lecture. Yeah, thanks. I hope you get the job, man. That it sounds totally sick. Don't stress yourself out too much about it. Just do your best and it'll all work out. That's what I taught to say. So yeah, I'm just going to knit them to false and then. I cannot intuitively understand why derivatives of integrals are inverse. Do I understand it? I mean, I always kind of sucked at calculus, but basically, can I run Linea on Linux? Yeah, I had, well, maybe mine was still when I was on Windows, but yeah, I mean, you can definitely run Linea on Linux. You should go to Bert Chan's page. You can search it up. I can put it in the chat right now. But I am trying to do it on Windows in terms of Windows XP. But yeah, derivatives and integrals, why they're inverse. Has your professor talked about, like, shown you in terms of like a graph, like what it is, right? Like, that was like mind blowing to me, right? Was, taking the integral, you become, you're basically taking down dimensions, right? Like, the quadratic becomes like into linear space. I don't really remember. The quadratic becomes parabolic, and then the parabolic becomes linear, or something like this, right? That's kind of how I understand integrals. Or, I mean, I haven't done this stuff in like fucking 10 years, but that's how I remember it. Was like, it's like we're adding on dimensions, right? We're putting it into another dimensional space in terms of, yeah, but not really. It's not really dimensions, because you don't just suddenly get a z component, but Sir went st towards formula. Yeah, I don't really know, to be honest. I suck at that sort of stuff. We're just gonna count, right? Okay. So now we can wait and close, right? If we are done, then we're not gonna block. We can just, wait and close, and it's just gonna wait an immediate thing. Now, so this whole thing with mem copying, we're not going to do this anymore, but just to implement this, I'll do it here. Just for, like, to figure this out. Now I'm hoping that, that this works. The NF shouldn't matter, but it does matter, to get back into the loop. Because this NF being 0, then it hits hits 1 up here, and then it goes back into here. So that's, I mean, it's kind of whatever janky, but let's just roll with it right now and see if this works. Okay, so also what we want to do, if done equals max threads, we have to make sure to 0 them, because yeah, we have to make sure to 0 them. I'm kind of trying to get away with not doing that, but it you know, technically, because it goes into this, then it should never be a problem, but it is kind of sketchy, but whatever. Well, that's not a good sign. That is really not a good sign. Yo, what's up, Luca? Long time. I haven't been streaming though, so. How are you? Are you healthy? Are you healthily employed at a not, you know, AI slop job? Oh right, I never set the threads to done. Oh yeah, I should probably do that. I should probably do that. Is you're unemployed? Good. In this economy, you never really know, you know. You're a sysadmin. Wow, that's so cool. Okay, there we go. I think this is faster. Anyway, there are no gaps between the frames because now we are, you know, are doing it continuously. Well, I mean, not continuously, but we aren't blocking anymore, just randomly. So, hey, I'm happy with it. Now let's fix the normals. That's the next thing. Should fix the normals, so that they aren't so temperamental. And so I just have to basically, the issue is you have to divide all of this by the amount of states, right? So can we divide it after or before? I'm just gonna try after. It's my mom's ID. I want to learn C. Hey, I mean, I think C is great, man. C is awesome. I'm right with you on that. It's been literal decades since I saw Windows XP. This was my childhood, dude. My dad's computer used to have Windows XP. You know, we had, like, typical American families had, like, a family computer sort of thing. And I remember that. My first game was Splinter Cell. Or Unreal 2, I can't remember. And then my mom got mad at him for letting me play those games when I was, like, a kid. I guess if we normalize it, it doesn't matter. I also remember maybe it was Windows 2000 though. I don't remember. At school we had the a computer lab class, you know, and we used to like play like the bookworm fucking game with the, you know. I remember that I think that was Windows XP or Windows 2000. My major is electronics and telecommunication engineering. Well, you sound more qualified than me. Can I explain what I'm doing? So I'm working on a 3D implementation of Lenia, which is a cellular automata made by Bert Chan, and he's or Chan. I hope I'm saying it correctly, but anyway, he's a brilliant mathematics guy, and him and a bunch of other math guys have been working on Lenia since like 2017, 2018. I implemented it in 2D, and now I'm trying to do it in 3D because I'm an asshole. And I think 3D is cool, even though it's going to probably end in disaster. But, you know, like 2009 fired it. Yeah, dude. You finished uni? That is, well, that's a big celebration. I hope that you you know, got the champagne out or whatever, you know, people do. You know, that's cool. Getting ready for masters. You're going for your masters. Jesus. Sysadmin going for your masters. Jesus. Watch out. That's crazy. Okay, so it looks the fucking same. So I guess if we normalize the vector, that it doesn't really matter how many states we have. Okay, well, never mind. I guess the normals are just the way the normals are. I think, honestly, the best way to make it better in terms of the normals is to just literally add more vertices, which, you know, isn't great. Took your girl to Spain. I've never been to Spain, but that does sound awesome. Studied C in third semester and learned nothing. Hey, you're probably more qualified than me. I never had a professor teach me anything about C. Our automata are implemented in code with a transition table? No, so there is no lookup table, but there will be lookup tables involved later when I get to it. Basically, we aren't even convolving kernels yet. We're about to, but basically the way it works is that we have some kernel, right, that's, you know, has a certain amount of rings to it and a certain, you know, parameters, right? And we are just convolving it across the entire field like a fast Fourier transform. And that is basically, you know, when we add in these sorts of a growth function and some randomized data, we can start to observe like a mathematical life start to appear. So where I studied, the college, and where I learned programming. I learned programming in high school from one class and then never again. I went to college for art. I went to college for music, for English, and then business. And I didn't finish any degree. Because I fucking hated all of it, to be honest. But, you know, it's whatever, it's in the past. So this is what the kernel is going to look like. The issue is, okay, so we have to do more cleanup first, because before we get into that, I have to refactor this a little bit more. I need to make this a back buffer and this a front buffer, what we started doing yesterday. So the goal is to lock one buffer and then a read from the other one, and then swap them so that we avoid the huge mem copy that's this mem copy right here, which is a really, really large mem copy. We can just completely avoid it if we just, you know, swap the pointers, basically. It's not going to be easy, though, because we have to initialize them separately. And honestly, that's kind of a pain in DirectX 9 from 2008. All right, I mean, thanks for hanging out, Luke. It's good to see you. I'm happy that you're outside of, you know, the world of working for, you know, the little you know, Bill Gates, Mr. Epstein files himself. Okay, so we want to make another vertex buffer that's going to be exactly the same, and that's going to be the back verts, so that we can avoid that. What's my closest degree to oh, thank you, I appreciate that. My closest degree to computer science? I don't have a degree. Honestly, I'm kind of glad that I didn't finish college. I did not enjoy it, and it was, you know, pissing me the hell off, to be honest, doing all that work. I think, you know, if I went back to school for computer science now, I'd probably enjoy it, but I also feel like it would bore the hell out of me. But yeah, I probably should have went to school for programming, but it just didn't work out that way. I had this internship at this music studio, and then that kind of just led me down that path instead, even though I was always like heavily programming the entire time. But, you know, You know, it happens. It happens. Okay, so how are we going to choose which one that we're writing to? Okay, so let's just have like literally an external integer. Maybe it doesn't even have to be integer, but it's going to just like curbuff equals 0, right? Technically, you want this in an array to be super efficient about it. I mean, yeah, let's do the little Zoring thing, I guess. Right, so we'll just have a back and a front buffer like that, and then we'll just, you know, do this. So we'll initialize both of them like that, right? Okay. So now that I have that, I need to flip them and then lock it when we start it. So when we go into here, I need to go and if you don't have a degree in CS, man, you would code. If I did this in India, the peer pressure would kill me. Dang. That's crazy that your whole family is that talented. You know, that's crazy. I really appreciate that though. I don't think I'm like that insane. You know, there was this guy in here yesterday that said something like Terry Davis died for this. It's like, damn. That was intense. But I appreciate the compliment. So we want to lock that one, right? And so we're just going to copy this code up there, and then we'll just write straight into it. And we will, okay, so that's what we'll do. We'll do that up here. And so what this is going to look like is that we're going to have this VA pointer, and then we'll do cellverts curbuff lock. What are you talking about? What? Is this? Oh no, yeah, that is correct. That is correct. I'm tripping out. My bad. I'm tripping out. Okay, I'm just not used to that. Okay, so now let's just put it in VA. The thing about the West, they are very chill. Just follow what you like. Yeah, I mean, it comes with its downsides, you know? Like, I don't know many people that live in America that are, you know, actually doing what they like. Most people work at, like, Walmart or CVS. Right? Like, the job, like, no one actually enjoys the job that they have, at least in the West, so. But, you know, that's what it is. So now there's going to be no memcopy, and we'll just unlock the curve buff. Right over there. And in that case, we want to, when we draw, we want to only be drawing the correct one. So I have to do that too. So this is going to be cellverts. No, this is going to be curve buff, the other one, right? And so let's extern that now, and then that'll be good. Oh. I didn't do it in the header. What? This is an error I've never seen. Definition from the for loop is ignored. The definition from the enclosing scope is used. What? Are you smoking? First of all, I don't even think that this I is being... Oh! What is this I variable even doing? You're writing an OS for watch and Rust? Cool. Like a watch? Like as in a watch that you put on your hand? That sounds crazy. I don't understand why it was mad at me for that I. Oh, okay. So that makes sense. Just want to release both of them. Okay, so we have these. It's definitely messed up for sure. It's definitely messed up. It's not supposed to be that temperamental. I don't think so. Yeah. Yeah, if I had to guess, we're probably reading from the wrong thing. It's ESP chip based, but Android like features. But what are we doing? I'm working on this this 3D implementation of cellular automata, Linear. Basically it's cellular math, cellular life made with math, basically. Oh yeah, of course. This goes out of scope. Duh. Yeah, that's got to be going out of scope. That's got to be going out of scope. Okay, so then let's just try this. Oh. Okay. Okay. Okay, there is some heap corruption going on. There. Oh, yeah, duh. You can, yeah, you cannot do that. Yeah, I need to close that out and recompile. Dude, like, this has just bugged out like crazy. Like, what is the problem? How long have I been doing programming? Close the active dialogue. What is happening? This is crazy. I've never seen this happen before. What? I've been doing programming for 9 years. This is like the craziest thing ever. Close the active dialogue and try again. It's end the process. End the process. Oh my god, what was that? I apparently messed up so bad that it broke the compiler. It's only the best way to learn C. I don't know. I just think like you should make a project, to be honest. I don't really think that the whole like watching a video. I'm not ignoring you. Okay, well, I may have written a bug, possibly. I may have written a bug. Oh, yeah, I cannot free V, of course. Duh. You just set it back to null, I think. Wait, but is that really what the bug is? I feel like the crash was... Okay, I guess that was what the bug is. Okay, is this... No, this is still... No. No, yeah. Yeah, it's still so temperamental. It's way too violent compared to what it was. I'm not ignoring you. Yeah, so that's exactly the same. I wonder if it's possible that we're... Oh. Wait, no. Don't trip yourself up. The only time we do it here is here. Yeah. I wonder if this whole Zoring thing, if I'm, remembering doing that correctly. Zoring it with 1. Maybe it has to be Zored with 2? No, I don't think so. Like if I just read from 1 or 0 the entire time, it should just... It's really interesting because the reason why it looks so weird is because it's it's skipping a simulation step, so it's only doing every other step now, which is pretty funny. That's pretty funny. Yeah, this happens before we display. Because display happens in here. Oh, by the way, hold on a second. We're displaying twice a frame. Okay, but that's still an issue. Yeah, I'm sure that there are good videos on programming in C. It's just like when I was a kid, or when I was like a teenager, there really weren't, and so that's why I always argue. I'm not against it, but you know what I mean. Yeah, it is so temperamental. Yeah, I mean, we should probably like log that we are always, swapping them properly. Yeah, we are doing curve buff, so it should be technically the same thing. Is this old Visual Studio? It is. It's 2008 on Windows XP. I don't think we need this anymore either. Yeah, because we have the global WIDX. Yeah, I should probably log it because I'm not gonna know. Yeah, I'm not gonna know otherwise. I'm pretty sure that this is fine. What I'm doing here is fine. Yeah. And me doing that in line actually isn't changing the variable, so... Or it shouldn't be. Yeah, I mean, so let me log that. The reason why I don't log things all the time here is because it's actually kind of painful to do it in this development environment. I can't just printf it. I have to do the thingy with the thingy. I have it here, the code. How do I know these knowledges from book or university? I just code a lot, you know. I just kind of get up and I code. That's why I've got 400 hours of doing it on this channel. Yeah, so let's just log it here. Whatever we have. It is so annoying to do this though with, you know, I don't know why they made it so hard to log things. Probably because, you know, you're supposed to actually, you know what, let's actually do that. Let's do it. Why not? Let's use the debugger. Yeah. I want to know which one is unlocked though, so I don't actually know that. I have to add like a breakpoint here as well, just to make sure. And then here, yeah. What would this look like in 2D? You should check out this. I'll give you the link for what it looks like in 2D, because I can't really compile mine right now on the other machine. But if anybody is interested in it, here are that's the main one by Bertrand. Okay, so if I can remember how to. Is it really this many in a row, or am I doing this wrong? Yeah, it is this many in a row. Okay, well this is ridiculous. I'm just trying to get to the next simulation step. Okay. Okay, that's exactly what I was worried about. So this is 1, when it's supposed to be 0 at that point. So this is now 0. This is 0. This is 1. This is 1. Wait a second. No, this is actually so correct, actually. Because this is, yeah. Let me just make sure that I know what the heck I'm doing here. This, I mean, it should be. But, I mean, whatever. Okay, so this should be, okay, so 0, and then the other one should be 1. Okay, so this is working, there's just some other bug. So it's not this, that's the problem. Man. Also, I'm pretty early on into making this. We don't have, like, very advanced kernels yet, so it's gonna look a bit different. Yeah, I'm kind of starting to get worried that this yeah, I am kind of worried that because of us multi-threading the vertices, we're just like creating some race conditions or something, which is pretty scary. I should also check that, I mean, they definitely all get the same pointer. No, like, no doubt about it. How's the project going? It's good. I'm having some trouble with just multi-threading right now. Like, the problem is that, like, so if we just have one draw buffer instead of, like, what I'm basically doing is I'm back buffering right now, is that, like, the simulation is running multi-threaded, and then when, you know, the next simulation step is ready, it just swaps the back buffer and the front buffer. The issue is that the reason why this is so, like, temperamental right now, it's not supposed to be like that. Like, you see how every other simulation step, it's kind of going like that. So I don't know what the bug is, but yeah, it's with that back and front buffer is what I'm trying to figure out now. But it's confusing because the numbers are correct, right? So we know for sure that when we are rendering, we're doing, you know, this, right? And then this gives us the front buffer, basically, right? So we know that works. But it doesn't, it has that bug in it. It has that bug in it or whatever, you know. But, yeah, you know, like we have a vertex buffer V, right? And then we do this, right? We lock it, right? And then we, you know, it gives us this into the pointer, right? V, it doesn't have to be allocated. It doesn't. No, it allocates it for us, right? And then when we unlock it, frees it. So it's not that. I kind of, like, maybe it needs to be mem set to 0. I don't really know, though. Like, that would be kind of weird. But we can try. I can try mem setting it to 0. Because this was calc before, so that might be a thing. Like, I don't really know, though. Okay. Oh. Oh, is that it? Oh yeah, that was it. Okay, see, so, like, sometimes I just need to rubber duck myself into figuring it out. But yeah, so it needed to be memset. Okay. There we go. Okay. Next up. Yeah, I think it's sick. I was really worried yesterday. I was, like, really stuck for, like, 3 hours. Just could not figure it out. But, you know, I thought for a second, like, that it would not work at all. I was like, okay, well, that's why this idea hasn't been done before, is because it's bad. But, you know, I'm happy that it's working. However, we don't really have kernels yet, you know? So it's going to be a lot slower later. So I'm kind of wondering if, now that we made this better, if I can push 32. I really want 32 to be the size, at least, that we can get. Okay, it looks like we can actually push 32. That's sick. That is sick. Yeah, the normals are still a bit rough. I think it looks probably a bit better if we just, like, you know, change the size down or whatever. But, okay, so next we can actually do the kernels now, because, so that's all, like, the optimizing I wanted to do with figuring it out math-wise. But yeah, it runs a lot better than it did yesterday, for sure. It also helped doing the multi-threading stuff, so that, you know. Okay. So, kernels. I have to pull up, so this is my second time making a Lenia thing. So I have on my other monitor the code. I can't really show both at the same time, unfortunately, but you're just gonna have to trust me. This code base that I'm looking at right here, my code base, is just a mess. It's like a real war zone. So I'm just trying to pull up all of the different formulas that I need. There's this this function called new bell that is the kernel function that we use to get the value in the rings. I don't really know. So there's a beta size and a beta. I don't really remember any of this at all, but I'm just going to kind of follow my own thing here and then try to write this init kernel function. So apparently it takes in kernel is a struct, but I don't really think it's that important. Yeah, it doesn't really need to be a struct. Maybe we should make it a struct. I think that there is a reason, because you kind of want kernel stuff to have a thing inside of it later. Okay, so we're gonna have a float grid. I guess we can allocate it. I kind of just want to do no, yeah, you can't do a grid with grid height. No, you can't. Let's not worry about allocating it right now. Let's just do 5 by 5 by 5. That's already a pretty big kernel, but yeah. Okay. So we need a beta. Wait, why is it a double pointer beta? Oh man, I don't remember this at all. There's also an RA. Yeah, I got no clue what this does, man. Yeah, this is complicated, because in here I had the FFT, also the FFT like real component of the imaginary value in here as well. I'm trying to find where this beta is being used. As a beta at the index. A beta at the index. So this is an array. An array of betas that are getting multiplied times the new bell. Oh gosh. Okay, well, I can't even. Oh wait, hold on. I know it's not called beta, it's called B. So this is callictier and then initialized to 0. And I don't see. I don't see where I set this up, so. Okay, well, I see that the B at 0 is 1 and the RA is 1. And I'm indexing into this via index, which is the fmin of floor R. Okay, I should probably be showing what I'm doing. Okay, so um I'm trying to translate this into like you know, code that I can actually use. um the min of the floor r, and the r is r divided by radius. If it's r is less than radius, times the beta size divided by the RA. Okay. So you know what? Let's just program it without the beta thing and then figure it out later. Because I'm not really sure how to populate that array. I think the beta size is the rings. And so since we aren't doing rings, we're only doing one ring around, I think we can totally wait to do that till later. Yeah. Okay. So I'm just gonna have beta size in the array. And then these will be initialized to 1, I believe. Yeah. And how do I get the radius? The radius is... Wait, what is the radius? Oh, the radius I take into the function. Okay, so then that'll be 5. Okay, so that should be it. Okay, so this will take in a kernel. Yeah, kernel. Yeah. Okay, so for now we're just going to loop through. So it's okay, so we have to do it 3-dimensional centered around 0. So we're gonna start at negative radius divided by 2. Yeah. Okay. Yeah, like that. And then I think so. And we just need to triple nest this. Yo, what's up, Deepin? How are you doing? So we just need to do this for every dimension. I've never done this in, 3 dimensions, but we're gonna do it today. That's what we're doing. Okay, so let's, we don't have Clang to yell at us here, so we can just do this however we want to, because we're like grown adults and all that. It's cool being a grown adult and not having Clang to be mad at us, All right. Okay, there we go. So now we're looping through the bounds of the kernel. This is going to be certainly difficult to do. So the implementation that I had last time, we need to get, yes. So now we get, so this, we will call this the Rx and the Ry and the Rz. And we need to square these to get the Euclidean distance. And then, okay, so we need to get the absolute value, right? So float x equals, oh, do we have fabs? We do have fabs. Well, I mean, technically it shouldn't be, but whatever. For now we don't care. How you are using old Microsoft Visual Studio? I have a computer with Windows XP on it, and this is a capture card. Okay, so we need to do this for everything, and then we will find the Euclidean distance. We don't really care about how efficient this is, since this is pre-computing, so it's whatever, right? Okay, so we get that. And now if our, if this dist is less than the radius, then we do the kernel update. We should also set all of it to 0, I think. The entire kernel. Yeah, we need to set it to 0. Initialize it to 0. So let's just memset it at the top. Once again, this is kind of, no, times R. We'll do that later. Music, sorry, the music ran out. Okay. Okay. So back to what I was doing here. So now this dist goes through this formula, and I totally don't remember what this is doing, but I remember it giving me a lot of issues. The beta size we will leave at 1, okay? And the RA is also going to be 1. But we'll do that, right? And we can have it here. The beta size is basically, if I remember correctly, it is the parameter that controls the, oh, I do have it. It's the parameter that controls the rings inside of a kernel. The 12th grade of this code looks super hard, bro, but I understand some points. So cool, thanks. I really appreciate that. It's kernel convolution, you know, the stuff that they do on photos to do all that, you know, fancy effects and stuff. Okay, I'm kind of copying my own implementation here is what's happening because I've done this before. And thank the Lord I have done this before, because otherwise I would have to remember how to do it again. So we are going to have, this is called emod. I forget what this function does, but I took this from somebody else's implementation. In C, I forget his GitHub. This was like a year ago at this point. So if A is less than 0, return B plus A, and then if A is greater than B, return A minus B. So if we think like logically about what this is doing, if A is negative, then we add B to A. If A exceeds B, then we return A minus B. Otherwise, we return A. Yeah, man, I don't really remember the point. Oh, man. So this is going to be the RR, so RX. So we need to do this with all of them, and then it is to the cell side, to the cell len, but the cell len is actually going to be this. Yes, yeah. Because we don't have kernels that are going to be the entire, or is cell len actually, no, cell len is, yeah, cell len is the amount of cells in a row. So I was just checking on that. So we want all of these. I'm pretty sure we want all of those. Okay, so we have all of them now. So basically, if we think about this, so this is our position, and if our position is, you know, greater than the radius, which it'll never be greater than the radius, no. It should never be greater than the radius. Okay. A would never be greater than B. But it could be negative, yeah. And then it would be B plus A. Basically what this is doing actually is it's centering us. Because we start negative on the negative side, so we're adding kind of it to offset us, I think. Okay. So our index is f min f. Did I implement min? I didn't. Am I gonna need to make it with floats? Man, that's the worst feeling in the world, having to do that. I could just make the macro, I guess. That's a bummer, though. Okay, fine, let's do that, I guess. Do we at least have floor? Because we need a floor. Okay, we do have floor. Okay, so let's just do that. I don't really know how to make macros. I always forget. So this is something that it's like Is it like... Is it that? Oh. Okay, so it is mad at me. I don't remember how to do this, man. Every time I do it, I have to look it up. Okay, apparently that's fine. Conversion from float to int. Wait, the grid is floats. Really, the R is really... Oh. I guess we can do this. Okay, so it's fine. Okay, so we compile. We have compiled. Okay, so this is going to be the min of the floor of R. I think that that's the correct R. Yeah. Okay, so this is something that we have to do. So this is actually not R. Or yeah, so we have to use the original radius. So this is going to be kernel. No. This is fine. Because R is their radius. Okay, so that's fine. The beta size -1. Okay, so let's just do this. I think it's just going to be 0 though, the beta size. Or maybe it's supposed to be the entire part of the kernel. I don't really remember. I'll have to read the code more thoroughly. But for now. Okay, so I had this float final, which is the beta time. So this is we don't have a beta thing, so okay, so now I have to implement this this function that does the, you know, called new bell. We shouldn't actually call it bell. Let's just call it bell. The only reason it was called new bell was because I had multiple versions of bell. So this function is like a sigmoid sort of thing. Let's just make everything float since we are on old hardware. So this is the formula you'll find in the papers where they talk about linea. It's a better, you know, version of the other formulas. There we go, and that's the formula. Now, do I know exactly what that's doing? No, it looks like a sigmoid though, and so we're gonna call it a sigmoid. So now the kernel K. So this, we're gonna call this the grid because we don't have a K. The real R. So now we're indexing into it, and we're giving it the final value. So this is going to be real X plus real Y times R plus real Z times R equals final. Okay, so now we have slotted in our first value into the grid. Okay, so now I was just reading, so in my implementation, all I'm doing is I zero the imaginary component for the FFT, but we're not worrying about FFTs right now. So all we need to do is I need to make a running sum value, which I called K cells. And this will just K cells plus equals final. And that will be the running sum value. The running sum value. Okay. Okay. So now at the bottom, all we have to do is loop through the entire thing, and we need to divide each grid's value by K cells. That's it. And that is how you make a kernel. That is how you make a kernel. But according to myself, that's how you make a kernel. So yeah, that's it. I hope that I know what I'm doing. I don't think I know what I'm doing. So for testing purposes, I think we just start with one kernel. We're just going to start with one kernel. Later, the goal is to have multiple channels with their own kernels, which is going to be more complicated, but it's kind of annoying, isn't it, that yeah, that is kind of annoying that we have to, yeah. This is why I usually have all my types in a different, you know, file, so that I don't have to, you know, extern stuff at the bottom, but whatever. This is only for debug purposes. We'll clean this up later. Okay. We have kernel K. Okay. Okay, so on our setup, when we do our setup function, what we want to do is set up a kernel. So K is going to equal a kernel with Y. whatever. It's mad. It's whatever. The beta size it's going to equal k dot radius equals r, and then equals 5, and then everything else will be k dot radius. I don't remember what RA is. Let's just set it to 1. And then the grid, we mem set it anyway. So let's call a init kernel with k. Okay. And now how do we convolve? How do we convolve is the question. So this doesn't exist anymore, right? Yeah, none of that works. None of that matters. We want to multiply this times the kernel value at that location, centered around. So this is going to be k. Why is this not? Do I have a polluted namespace here with k? Okay, maybe we don't call it k. Maybe we call it kernel, I guess. I'm just worried because IntelliSense is already mad at me. Okay, so is it going to be less mad at me now? Oh. Right, it's a dot. Like, what is wrong with me? So this is going to start at negative kernel radius divided by 2, just like when we iterated it before. Oh wait, hold on a second. dx is actually in world space, so so it's x minus x plus. Yeah. Okay. So now we should be able to index into it. How do we find the local space? You know what? Let's do this a very simple way, and let's just not overthink it. Does C98 allow me to do this? Well, we'll find out soon enough. Oh, I also, yeah, so this... Yeah, I think it's probably faster for us to do it this way, and then just like literally just increment it like this. Even though it seems kind of disgusting, it makes sense to do it this way. And now, so if this is, yeah, so this makes sense. If we're in the center, we want to continue. Otherwise, this DIDX, this works. So if we're inside bounds, then we go n plus equals cells DIDX, and now we're times kernel dot grid indexed by, and now we use the kx plus ky times the radius plus kz times the radius. Okay. So I have no clue what is going to happen here. Okay, so we have some compile errors. Conversion from float to int. Really? I made that a float? Who cares? Ambiguous call to overloaded function. Oh wait, hold on a second. This R is supposed to be dist. Dude, like, what is the problem? Like, what? Alright, peace out. Thanks for hanging out. If I just leave dist in here, is it fine? No, it's not. Okay. So argument conversion from float to int. Where is the conversion from float to int? I think that R less than beta size has to be... Yeah, R less than beta size is actually dist. All of this R stuff is actually dist. The index stuff is dist. And so this is actually dist, but truncation from double to float. Okay, like, this is getting ridiculous, man. Oh, kernel. Okay, we're almost there. Conversion from int to float. Yeah, dude, like, yeah, just cast it, man. Like, okay, well, that one's on me. Is it 86 bucks or some virtual machine? No, this is my computer. I have a computer with Windows XP on it. Identifier not found. Oh, it's not in the header. My bad. I don't even have this header open. Okay, I don't expect this to... Okay, so yeah, so that makes a bit of sense. I was not expecting us to get it on the first try in terms of the... I have to do the growth function now and figure that out. So I have to figure out how to do that again. Because of the growth function, the kernel is reliant on the growth function to do it. So I have this lookup table for the growth function. So it is... Okay. Okay, so it looks like it's actually just the new bell. And the M and the S. Yeah, so it looks like it's just new bell, actually. But I'm trying to find what the M and the S are. When I do a growth lookup... Oh, I guess I just set it to a constant value. Pre-compute growth table. Kernel.m and kernel s. Okay. So the default, I had this at 0.15 and 0... Yeah. So that's what that is. Well, episode 3, we're back in business. We are back in business. We are. So we just need to do new bell, basically. At least from what I understand here. So okay. So we use the kernel M and the S. But what I did was I just had this hard coded here, the M and the S. So I'm not really sure, but maybe let's just like not freak out about it for now. And so basically this is going to replace this, I think. So we sum up all of that, and now down here, when we put it in the back buffer, what we have to do is, we're adding, there's also something that gets divided by number of cells, but I'm not sure like what that is doing, what the U is. I have two different arrays, one U and one G. Once again, if you want to see what I'm looking at, I'm looking at this. I'm looking at this. Okay. Yeah, I think so. I think that the G isn't the U isn't important. I think that the U isn't important. I think it's the G that's important because I think the U is only used for uh, some debug things. I think the G is what we care about. Because I don't actually use the G. I add H here, and I don't know where H is coming from. Oh, I fill H here with the G. Okay, so G is what we care about. G is what we care about. So the whole dividing U by the number of cells. Oh shit, we do care about it. So what is U? Oh, U is when we execute the DFT. Oh. Okay, so let's not worry about the U DFT thing yet. Let us this is a similar. Yeah, it wasn't necessarily on Linux, but it was 2D. It's a normal kind of 2D linear implementation. Yeah, so that U is the raw FFT that needed to be normalized by the number of cells. But I think since we don't have an FFT yet, we can skip that step and simply do the bell, and then the bell is going to have cells IDX. Yeah, that kernel's K growth table times 2 minus 1 is kind of confusing. Times kernel's K H. All of that is very confusing. Like what is the type of this? It's a double pointer. To what? To a table? But then how am I multiplying a table? I don't remember this at all. You know what? I'm just going to hard code this at 0.5, 0.15 for now. And then okay, well, now we get nothing. Now we get nothing. Okay, well, now we're in the thick of it. We do also have to clamp this. Actually, very important to clamp it. Honestly, so this should actually be between 0 and 1 now. We don't want to have states. We do not want to have states. Okay. KSI? Okay, well, oh, wait. We aren't actually using N. We aren't actually using N. N has to be in U, I think. So is it that? Okay. It's not that apparently. Dun, 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 dun. I hope I didn't do 12 here anywhere, but growth table. Where's this? Where do I initialize this variable? Pre-compute growth table. Oh. Kernel M and kernel S. Right, so every kernel had a pre-computed growth table. Got it. Got it. Got it. Yeah, we don't have to worry about that right now. But you know what I want to do? I want to print out the kernel. And so that's what I'm going to do. I'm going to debug this, I think that's the easiest way to go about it, is to print out the actual kernel. And I have code here that did exactly that. Yo, what's up, Switzerland? I have code here that did that. Basically, what we have to do is we have to have and we're just going to do the same pattern. And so if well, maybe not. Let's just God, this is annoying because of the whole printing out shit thing. Okay, where did I leave this piece of code that yeah, so let's just do this, and then here, why is this not? Okay, we don't actually need a conditional here. Yeah, let's just do this. Okay. Oh, that's annoying. Okay. So this is going to print out, we just print out the grid value. And then just every row, we just want to Yeah, just a new line. Oh, well, that's fucking annoying. That's really annoying. I don't need to know that the threads are exiting. Like, oh god, what did I just press? No, go away. Okay, so I had new lines after every value. But this isn't. Oh, it is after every value. Because I did it wrong. Oh, wait, because we don't have the nested. Okay. Okay. Well, why is it like this? Why are they not concatenating? Did I put... Oh yeah, I did. My dumb person body dummy. Okay, so this is the kernel. Except it's not the kernel. It's not the kernel. Oh right, it's in 3D also. So it's in 3D, so this is like way more complicated than... Oh my god, that's... Yeah, how do I even print it out in 3D? Like that's This seems crazy. So this is 0.9. This is 0.0. Why is the first value so high? How do I even print something out in 3D? Something else I'm noticing though is that our kernel's radius is 5, but then, you know, we get collapsed down to this. And so, yeah. Also, radius isn't really the best way to describe it. It's actually not radius, it's diameter, but the problem is this is gonna break it if I do this. It's just gonna break it. There's no way that that's gonna work. The thing is, it's in 3D, so we have to go 1, 2, 3, 4, 5, right? And then this is an entire slice of the kernel, right? And then it should repeat, but it's not repeating. 1, 2, 3, 4, 5. Oh wait, no. It is because this matches up with this, which is another slice. 1, 2, 3, 4, 5. They should be symmetrical inside themselves, is what I'm saying. So 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Yeah, so that's symmetrical. And then 1, 2, 3, 4, 5. Symmetrical again. However, the values themselves are obviously 0.9, 0.1 being right next to themselves. Can you assume how difficult it is to patch all the vulnerabilities to make it compatible? I don't really know because I don't use the internet on this machine. This is a capture card. Yeah, this is bizarre here. It's very strange. These ending values. The rest makes sense. Like this makes sense in the middle actually. Like kind of. It's kind of weird. Yo, what's up, Shari? Yeah. Trying to think like mathematically what the calculation is that's it is exactly symmetrical, which is good. Like our iteration is correct. Our result is not though. Also, we don't need a well. Now maybe we don't need to do this actually, because if we have a radius of 5 and then it gets tapered off every time, it gets collapsed off, whatever, every time. Oh, that's a bug right there. Okay, that was a typo. Glad I caught that. So have you studied the history of the internet back in my school days? I wish that they taught the history of the internet in school. I don't think that they do. Though I guess I'm kind of getting to the age where I lived in the history of the internet to some degree, I guess. We are using dist r times beta size divided by the kernel r ra. Okay. Oh fuck. Yeah, see, this is kind of bizarre, right? Because now they're not equal. So I'm going to go assume C++ or Rust or Zig. Say they're C++ or Rust. I don't really, not gonna start any drama, but I don't, these kind of newer languages, I don't know, aren't very reliable. I don't really think that they're good for certain applications. Yeah, it's got like this X shape to it. What could be causing that? The thing is, so this in the middle, circular, it kind of works. It kind of makes sense, right? What doesn't make sense is that this is supposed to be here. This is supposed to be here, 100%. That's supposed to be here. If that is there and then this is over here, it's perfect. How to code? I don't know either, man. Yeah, this is also over here and here is also the same thing. Where it's like, for some reason on the sides it gets, maybe let's get rid of the beta size thing. Maybe like this to, maybe just get rid of the beta size check. and then just like try to do just basic. Let me give me some tips. Tip 1, use keyboard. Thanks. Thank you. Oh shit. Uh-oh. I think it works now. Yeah, this is it. This is a donut right here. So this, as you can see, the corners of this kernel are symmetrical and they're less than the rest of it. That's what a kernel is supposed to look like. I think due to the beta thing. What's up? What's up, Yash? I sort of feel really insecure about my future. I don't want to live a mediocre life, but I know what would be the right path for me. I mean, I don't think that there's anything wrong with a mediocre life. I feel like I've lived a strange and crazy life, and I feel like I would have been much happier if I lived a mediocre life. I think that the people who live mediocre lives are probably the happiest people in the world. So I don't think that that's something that you should be afraid of. Okay. I think sucking at things is much better than being good at things. I'm living great life. I don't really know about that one. I live a life though. Okay, so let's see if what we're doing now makes sense. I don't think it will, but I think that the bell is it's gotta be. It has to be that It's crazy though. I wonder if when I was going through this before, if in our update loop, I started normalizing the normals, and I like divided them by 12 for the central difference. Now I removed it. This is technically C++, but really C. I mean, basically. So let's how about this? Let's just breakpoint it and then just like step through it again and again and again and again until we, figure out what the problem is. Because now that we have the kernel working, there's really no reason that it shouldn't. Oh, yeah. You gotta do this. Oh, but how do you do that? Kernel radius +1. How does kernel convolution? That's the whole point of Lenia, actually, is kernel convolution. That's the idea behind it. The idea is that you can bring this into a continuous space with kernels. But in 3D, this is much harder than in 2D, for sure. Yeah, it's kind of a pain in the ass, for sure. So it went out of bounds here. So this would be Z -2. No. This makes sense. Because this is greater than or equal to. Yeah, that makes sense. No, yeah, that totally makes sense. Okay, so let's breakpoint it, and then you can look up. I'll give you the link. Here you go. This is what Lenia is. Okay, so let's see. Okay. The things happening in India are forcing me to work hard and leave from here. Yeah, I'm sorry to hear that. I am sorry to hear that. That sucks. I wonder if... Do I... Oh... I think my... Oh, yeah, ISO value. Okay, so I was like wondering why... why this was so stupid, but if the ISO value is... Okay, no breakpoints, please. No breakpoints. Okay. Okay. So... I mean, we aren't updating or changing at all. But this is what early Lenia should look like. Is kind of this coral sort of pattern. It looks like this in 2D as well. On the inside, it looks kind of cool. But it's kind of like full of knots and stuff. But, so we aren't updating anything. We aren't updating or anything. We are not updating or anything. Maybe this is equals instead. Okay, well, apparently not. Apparently not. Yeah, I mean... Our kernel is... It should be pretty correct, but maybe this this growth function is way too big. Let's try 0. Let's try this. A less growth maybe. Yeah, it's weird to see no changes at all happening to it. It might have to do also with our ISO value. We might have to tweak it. I want to try it lower, I guess. No. Okay. No, they are not voxels anymore. We are meshing. We are meshing. The reason why it's not... So we're convolving a kernel in 3D, so I'm probably like... I don't know. I don't really remember how the update loop is supposed to look. I'm sorry, I forgot to put on music again. I keep forgetting. Well, that's an ad, but we're gonna skip it right here. Okay. This is kind of how Lenia is, though, is that you either have like a lot of movement or it just kind of gets stuck. That's kind of normal, though. But I just want to make sure that we're not doing anything awful with it. So we're normalizing it by the sum, which makes sense. Oh, but when we normalize it by that, it's just so... Okay, hold on. So this is not the final. This is not the final. That's before it's normalized. So that's why it's so small. What do I think about Frutiger Arrow? I think Frutiger Arrow is cool. I grew up with XP though. I think XP is just such a sick. I don't know. This is a really cool era of computing in general. It's like 2001 to like 2005, 2006 sort of thing. So the kernel is, I think the kernel is fine, but how we're using it probably isn't. But I'm trying to find it in my code where I did this last time. I can show it in a second. What I'm looking at. Here. This is what I was trying to do, right? The weird thing is that, like, I don't really know. So UK is what comes out of... comes out of something, right? Yeah, the problem is that I don't really remember what the fuck this this code is doing. I think UK is the FFT, right? And then it comes into here. What it might have to, we might have to. I wonder if we need to divide this by the number of cells in the kernel. That might have to be what we do, because there is that... What are my PC specs? For my... for the stream, I have a Surface Book 2. For this one, I have a Windows XP. Okay, so let's pivot back. So I'm thinking maybe we try... Let's do this, and then just like... Also, I don't think that we continue on the center anymore. So let's just do k count plus plus, and then divide it by that. No. No, that is not it. If I had to guess, the reason why we're not seeing any change is because I'm clamping it. If I unclamp it, I guarantee that this would start moving. Okay, I lied. I was expecting it to actually do something there. Though. And I don't know what the H is here either. Yeah, doing this in 3D is just hard because no one's done it before, so it's not like I can be like, oh yeah, this is the wrong output, you know? Like, I don't know what the right output is because no one's fucking done this before. Oh, hey, what's up, Some Musician Problems? How are you? So I'm trying to find where we... The grids equals the clip of grids plus the t reciprocal, which is the time step, times h. and h is what is divided by the k count. And k count is the kernels, the amount of kernels. So we're adding the kernels together. And right now we just have 1, so that would be 1. So we have to multiply times the time step technically. Technically speaking. So you would have to go like times 0.1f because of the time step. Yeah. So really that doesn't tell me anything because we already have this. That's already what we have. Well, I mean, I don't know. Doing some C++ work? I'll listen to you. Yeah, I mean, feel free. I hope that that I'm, you know, a good study partner, I guess. Yeah, because if we don't do this, then there's nothing. Oh wait, there is now. There is now. I think 0.15, 0.05 was like, let's just try it like really small, I guess. Yeah, that boy's stuck in time. That boy's stuck in time. That boy's stuck. You know that yeah, that's a good, funny video. Why is this so hard? Let's go and see what are some values again that we can take a look at. So this is 1. This is 0.008. Okay. Well, let's just break it down here and then see. What's the result out of this? How do I check that? That would be sick to check. Man, it would be awesome to be able to check that. Why does it not let me evaluate that? I would love to be able to check that. Is there a way for me to like do this at watch? Okay, but whatever. Whatever, man. Let's just make that a separate value then. Oh, snap. Whoops. Okay, so this is -1. 0. 0. 0. 0. 0. 0. 0. 0. 0. 0. 0. 0, 0, 0. Yeah, maybe I have to do this inside of here. Windows XP indeed. Let's try changing the values back to what they were. Now let's see if we get like less zeros. Wait, why? Oh, did I miss a... Wait, why here? Wait, what? Can you shut up? What does sprintf s even take? Can you shut up? Shut up, shut up. Like, who are you, dude? Like, shut up. Oh, okay, so we... Okay. What? What? Truncation from double to float. Okay, shut up. Okay, well that one's my bad. That one's my bad. I think it's supposed to be this. Well. Okay, so let me see. So negative 0, 0, 0, 0. Really, I don't think B should ever be 0. So maybe I'm not supposed to do this. I don't know. Negative 0, 0, 0, 0, 0. There's just so many so many zeros, like, and this is 6. Oh wait, am I being stupid? No, yeah, this is 0. Wait, so does this function? This is the exact function that I was using in when I did this last time. But maybe it's maybe this is not good. maybe we need like 0.5, 0.15, like I don't know. The value is still 0. Can I explain what I'm doing? So right now what I'm doing is trying to figure out how the growth function works in linear in 3D space, which is kind of non-trivial, but it's kind of a pain. But that's basically what I'm doing. Is I had this formula in my last implementation, and it's not working in this. So I don't really know what to do. But I'm trying to make it work. I'm trying to figure out, like, how do I get this to not be 0? Like, it's just 0. Which, you know. And a reason why I'm using XP for this, I like old computer graphics and I like the challenge of doing old computer graphics. I don't like how everything is shaders nowadays. I just don't find it very fun. Dude, this is like, this is so sucky. Is there any reason why? So n is non-zero. So like if I try something like 0.5 is already a crazy value. Like, maybe it's n that's too big, actually. Maybe it's n that's too big because we didn't like divide it by k counts. The annoying thing is that it's just 0. You know what I mean? Like, it's not it's not like 0.000001, which makes me feel like I have to be doing something wrong inside of the growth function, inside of here. But this is exactly what I had before. I wonder if something is getting like casted or something. M minus S minus X minus M. So that would be like 6 minus that much. Let me make sure that this is the exact code that I had, because XP minus pow. Oh shit. Oh wait, no. No, it is. It is correct. It is the exact code. It is the exact code. Yeah, it's the exact code. So if it's not working, then maybe it's got to be something else, right? I mean, the only thing that's different is that my code uses doubles. So we could try changing everything to double, but I doubt it. Doubt that that's the problem. Oh, and it's also going to get mad at me because it's going to be like, oh, we cannot cast it to a float or whatever. Oh, well, it didn't actually. Well, it doesn't matter though. I like, it's so strange because that exact, this exact function is what does the kernel, which computes the kernel. It's the exact function. It's the exact function. It's the exact function that does this. And it works fine here. We can try like a constant, just to make sure that we're not like, oh. Okay, well. Okay, well, hold on a second. Okay, so that would be why. It's just too big of a number. Just n is way too big of a number. Okay, well, let's do this then. Let's print out the kernel. Let us print out the kernel. And we don't have to do it like super fancy. Let's just do it like this. I just want to see this. Okay, well, I wanted to break on that line, but now it's just like, it didn't want to break on that line. So let's just remove that breakpoint, I guess. Oh, did I remove the other breakpoint and now it's mad at me? Okay, whatever. I mean, it's completely very, very small numbers all around, just super small. And we're knitting to so let me make sure here. So n is this is 125. Maybe it's like doing some weird casting bullshit. I mean, it's already afloat, but no, it's not. What is K count? So 5 times 5, 25. Yeah, so it is correct. It is 125. There's 4 divided by 125. What the fuck are you talking about? What the fuck are you talking about? Wait, what? What? What are you talking about? That's crazy. Wait, why is that a thing? Oh wait, hold on a second. This is E. Wait. Oh shit. Wait a second. That's actually a huge number. Never mind. I'm being so dumb. Wait, but how? Oh, wait a second. Hold on. I could have done that wrong, I guess. Wait, I may be indexing this grid wrong. No, 75 is fine. How did I first get into programming? I learned when I was a teenager. When I was in school. And then I was like, damn, this is kind of cool. You know? Yeah, I'm sorry. I'm stuck in this right now. So I would go home and then I would, you know, program like terminal applications and stuff, and like bring them in to show my teacher or whatever. And yeah. So wait. So 5 times 5 times 5. So I'm doing the thing again. No, I can't believe that I'm doing the thing again. Oh my god, I can't believe that. God, I'm such an asshole. Yeah, I'm sorry. I am sorry. I feel bad about that, yeah. Sorry. Yeah, I'm stupid. Yeah, I'm stupid. I'm so stupid. My bad. I don't know why I feel so apologetic, but yeah, that's my fault that I was stuck on that for so long. I was just indexing it wrong and I just totally didn't get it. Okay, so yeah, now we're changing. It's not like the most exciting thing ever, but because it is like kind of, you know, whatever. Now we can try different values for this though, which is cool, and then see how it affects it. Okay, well that just made it more stable. Yeah, I don't really know. I think that this, if you go higher on this, then it becomes less stable. Yeah, it dies out. So yeah, we have Linnea working now. It isn't like the prettiest thing of all time yet, but Linnea in 3D, it's real, it's here. Yeah, it is kind of touchy with the growth function. That's why I had it set at that, was because that's kind of like a good like starting point. If you go like, if you touch it too much, then it, yeah, it's kind of whatever. Yeah. Wait, why is that happening now? Okay, I guess I had it at something else. Okay, so now let me, a good thing that we can test now is actually the ISO value. We haven't really touched the ISO value, but 0.5 might actually show us something a little bit different. Yeah, there's not a lot of change, to be honest. So there are a few things that we can try and do, but yeah. The real Z is okay, yeah. So this is the what I used before to do the kernel you know, thing, and so we could test it out. The annoying thing is that, like, yeah, what we could do is we could just like say if I are and then we just, you know, do a new line, just so that we can print out the kernels that as we're doing them. Okay, well that... Am I stupid or something? Oh, what, like, yeah, I am stupid or something. Okay, so let's see what our kernel is like right now. Oh my god. I'm off by 1 on the thing because I didn't do it. Okay. Da, 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 da. Oh my god. Dude, just leave me alone. Okay, we're just gonna put it at the top. Programming is annoying, man. Okay. So... Oh, it's gonna be asymmetrical because we aren't going in through the right order. We have to literally copy this, basically. We have to go through each axis and then do it like that because it's not in order. It's not in the same order. Okay. Well, that's kind of painful, but I think it's necessary. Okay, so let's just do that. Do some looping here. We're just gonna start at 0 and go to the kernel radius though, this time. It can at times be very, yeah, I do get mad sometimes. I can't lie. I cannot lie. Well, I can lie, and I do lie sometimes, but you know. Dude, me doing the helix key combinations is so funny to tab it, but I'm not in helix, I'm in Windows XP, so I can't do that. It's funny. This could be less. And so. Yeah, so this is this, and then we're going to do, oh, we're gonna do the same thing here. We're gonna make the same mistake again. Oh no, because this is starting from 0. That's starting from 0, so it's fine. And now we can print this out properly. Hopefully they are now contiguous. Did you mean to use... Oh. Like, shut up. What's the problem? Oh, we taking in a kernel, but it should not be. Okay, well, okay, it technically is a pointer, but we just have a global also, so that's confusing a little bit, but whatever. Let's just satisfy the compiler. Hey, what's up, Redbox? How are you? This is C++, but really just C. I won't tell anybody if you don't, though. Okay, let's see. Let's see. Okay, so are we... Is this a kernel? Is this a proper kernel? Or are we... You're also a programmer? Cool. Cool. I wanted to see the values, making sure that I'm indexing it right because it doesn't seem correct. Oh yeah, you know what? Of course it isn't going to seem correct because it's in 3D is kind of the problem. So this is technically... Plus one sub, thanks. I appreciate that. Thank you. Yeah, and yeah, so if we print it out from here this way, everything looks good. If we print it out from here, everything looks good. Because we have real X, real Y, and real Z. The problem is, I don't know if we index into it the same way over there, is the thing. Ever thought of using Rust again? Not really, to be honest. I don't know. Yeah, see, so this is circular. This is circular. This is circular. I don't know. I think Rust is cool for what it's trying to do, but I also don't think that I'm, you know, I got guitars in the background. You know what I mean? I'm not I feel like, honestly, you gotta be kind of a square to program in Rust, to be honest. It's just not for my personality type. I don't know. I'd never really got along with it, I guess. Could it be this? That doesn't make any sense, right? Well, code, this is C++, but really C. That wouldn't make any sense. No, this can't be. I didn't segfault though, which I should be segfaulting there. Yeah. So this is the kernel when we're iterating it. Personal preference is Rust over C++. Couldn't understand move semantics, L values, R values. Yeah, I mean, I don't use all the, C++ features. I'm pretty much just a C guy, to be honest. but I do kind of feel like Rust is very frustrating to work with for me. Weird thing is that maybe it isn't symmetrical. Now looking at this, oh man, this sucks. This fucking sucks. Okay, so our values are not in the right order, for sure. Like 0% chance that they're in the right order. There's a 0, 0, 0, 0. Okay, so here's what I'm going to try to do. I want to make sure that one of the axes is correct, at least. Like, I want to just try switching the axes around. What? What is the problem? Oh. Let me see. This axis. See, it's not symmetrical, which means that it's off somehow. It's not off when we push it onto the kernel, but it's off when we index into it later. Really, this shouldn't matter. Us switching it actually doesn't matter because we're looping through it anyway. So, yeah. Yeah, that sucks. So I think we, I don't know what to do. This emod thing might be incorrect. To get the real X, real Y, real Z thing. I kind of want to print out what that is. I don't know how to make it readable though, so it's gonna be shitty. So. Oh, I put them in the wrong order. Why did I choose C++ over C? I didn't. The compiler chose for me for Windows XP. I think you gotta be like even more of a masochist than me to choose C89. It's like actually disgusting to program in, so it was not up to me really. If it was up to me, then, but I mean C++ is just C, you know, like you don't have to, it's just the standard is different. Starting at 333 is very strange. Because we should not be starting at 333. Really, like this starts at negative radius. So us starting at 3 and ending at 2, that cannot be correct. That cannot be correct. Here we get to 0. I think we do get through all the values, but it's very strange how we get there. Like, this is the first one we do. It should technically be at 0, 0, 0. Like, there's absolutely no way that that's not supposed to be at 0, 0, 0. So the values for our kernel are correct. We compute the kernel correctly. It's an indexing problem. And it's actually non-trivial to index into it because of reasons. What to do? First of all, let's try this. Let's try that. Because that's exactly what I have in my previous code. We changed it because it was not looking great, but we start at 333 still. And now this is completely ruined. Okay, well, shit, I guess. I don't know. Okay, so another thing here with this beta size -1 thing. That's a good question. For my index, I did this. Let's get rid of that. Let's just do the floor-f of the dist. Shouldn't matter because the problem is with our real z and real x and real r. This is exactly how I do them in my other code. Is this function. I believe it's exactly that. I believe it's exactly that. I don't know where the code is though for it. Okay, here it is. Yeah, it's this code exactly. It is exactly this code. Maybe I have to just like think for myself and do it myself though. Also, let's make sure this is the floor-f of the dist. Okay, yeah, that's correct. Oh, you know what? This is probably the actual. Okay, hold on a second. No, that can't be. Oh, maybe it is. Okay, we didn't segfault, which I was expecting to because of the bounds there. Oh. Yeah, that can't be correct. Yeah, it can't be correct. Okay. Here's what I'm gonna do instead of doing this is we're literally just like not gonna be stupid anymore and we're just going to count them separately. Like abs z is what we should be using. So let's just get rid of this and then just use abs z and try this. I don't know why I didn't do it like that in my last implementation, but maybe it's a sign that I did it just stupidly. Okay, well now it's just all zeros. Access violation. Reading location access. Oh, because of this, I'm being dumb. Hey, what's up, Mano? How are you? Actually, I'm one off. It's supposed to be this. I use Windows XP as regular basis. Do I use browser? I don't actually use a browser on this now. No, I don't. Oh, what is I? Oh my gosh. Yeah, I don't use the internet on it. It's just too unsafe. What is the problem? Oh, I did the thing. Okay, we don't want to edit that. We do not want to edit that. Okay. Hey, what's up, gamer? Yeah, I have another computer. This is a capture card that I use to. I'm doing okay. It is what I'm doing is sort of frustrating. I'm not gonna lie. There you go. Is the XP system a virtual machine? No. It's on my computer. On my other computer. Okay. Okay, so this is correct. It's just that we aren't iterating the full thing. We have a 4x4 kernel now. Yeah, 4x4 kernel, and we want a 5x5. Let's just go greater than or equal to. Okay. Okay, so it died out that time, but that was more correct, it looked like. Let me take a look at what this looks like. Is this circular? It is not symmetrical. This is not symmetrical. But then again, we don't really know if... So the order we go in is across. Now, see? So that is correct. And now let's make sure that I didn't mess up the indexing when we were debugging this. Yeah, so I did this. I messed that up. Okay. Okay, we are symmetrical again. Okay, good. So this is a slice of our kernel. Which is just, a circle, right? And as you can see, the next slice is going to be getting closer to the center. You see, so if we're thinking about this in 3D space, right? We have a 5x5 kernel, so that's one slice, right? And then the next slice, we're going to be getting closer to the center. So the values, the magnitude gets higher and higher. And then again, we're now really close to the center. And yeah. I did just notice something though, that this is off, isn't it? This. Oh, yeah. So the center of the kernel, the exact center, is less. It has a ring, basically, you can think of it. So that's what this is. That's why the middle is not the strongest. But near the edges, it looks like the middle is the strongest, because you can think of it as like a sphere with like a hollowed inside, right? And we're stepping through the slices. It's pretty cool. So that's working now. That is working now. But I did notice that we died. Which is bad. You don't want to die. But we did die out. So we can try messing with these. that just halted growth completely. So that's that. That's my question answered there. We're gonna make a UI for this at some point. That's my last thing, is that I made a UI to change these values during runtime. So we're gonna do that soon, but yeah. It is touchy. It is for sure touchy. Okay, well that's pretty much linear without, you know, fast Fourier transform. Tricky thing is really now getting it to live and not just die immediately whenever we change something. Okay, so that's that. That's making games on Roblox. I've never tried it. Is the engine shelved, the PS1 aesthetic engine? I don't think it's like shelved. I kind of like doing retro graphics, right? And I feel like I was always, you know, using OpenGL, right, to make graphics, and I was stuck between two worlds, right? Because people were like, oh, you know, is there this, you know, ray tracing, or like, not ray tracing, but like, you know, materials and PBR pipelines and this and that and this and that. And I was just like, man, I don't want to make an engine like that. You know what I mean? It's not what I want to do. Reason why, I think modern games look shitty, even the ones that have like a retro aesthetic. And so why make a modern engine when I don't even like modern games? So that's kind of what I add. I'm sure that there are like cool you know, games, but I think like in general things just become, you know, shittier, you know, in terms of like, I don't know. I think personally, like as an artist or whatever, man, it sucks to just like be able to do anything, to have like every fucking knob in Blender, you know, that you gotta like learn, and this and that and this and that. It just makes you so uncreative, because to learn how to model and how to like make textures and how to do all this and do all that, all you do is you just end up copying other people, because it's the only way to learn all these fucking knobs, all of this, all that. You have to just watch somebody's tutorial, somebody's this or somebody's that, and you just copy those things. Like, where is the originality? Where, like, this is the reason why every game looks the same nowadays, because to learn how to make a game, you gotta just copy people, because it's so goddamn complicated, man. I'd rather just learn it and it be intuitive like this. Favorite game aesthetic? Oh, dude, like that's tough. I mean, I obviously like, I love Quake, but like if I was to give my favorite like game aesthetic, is kind of hard. Um, I've got a lot of favorite games. I love Wizardry 7 is like one of my favorite games. And Wizardry 8, like both of those games are just like kind of amazing. I think Wizardry 8, in terms of like visual aesthetic, these like low poly sorts of things, and the animations are just great in that game. Um I spent a lot of time like playing like Counter-Strike when I was a kid, so probably that. And I love Xenoblade Chronicles actually. The first game is I think it's just a brilliant story. It's told like really excellently. Um, I think all of like the philosophy of that game is just like, it's brilliant. Um, it's the last good thing that what was it? Is that a Nintendo game actually, or is it a Square Enix game? Um, that's awesome. That's an awesome game, man. Um, crazy ball knowledge. How do I stay consistent with coding? Can't go past 3 to 4 days without burning out. Honestly, I think streaming and making content like this helps a lot. But I mean, I did it before that. But yeah, I think like having the idea that like, oh, I have the ability to show this off at some point is good. I think like even if you have that without streaming, like just a friend that you show your shit off to, is probably like that'll help. But yeah, I'm probably like missing so many games. But yeah, I like well written stories and well written games, for sure. You're writing some demo stuff on Windows 11. Just thinking might go back to Windows 7 Legacy. Yeah, I'm kind of lucky because I have a an old computer that I got out of the garage that I run Windows XP on, so I don't have to like give up my computer. But I mean, my computer sucks. But yeah, I think it's good to have this one still on Linux, for sure. What IEMs are those? I don't really remember. Um, they're Truth Ear, something. They're pretty cheap actually. It's like $25 or something, like 35. Um, the last IEMs I had I forget which ones. Those were expensive. Those were like 100 something. But those broke like a year or two ago. It was like snow. It was like white ones, which were super fancy. But yeah, yeah. I'm gonna go. So I have the Bert Chan kind of tutorial here on it that helps give like checkpoints into what we're doing. So we have the we've done. Okay, I can show this off while I'm talking. We have done the multiple states, right? Then we have gone into having a normalized kernel, right? Now we have continuous states and time, right? This is pretty normal, right? I just have this 1 over t is the 0.1 that we multiply by, and yeah. I want to make sure that the t isn't anywhere else I'm forgetting here. No, it's just that. And this is, if you want to see what this looks like, in 2D, right? It's like that. Sorry, I can't read chat while I'm doing this. Planning to build a retro case and then I'll install Windows XP? Yeah, go for it, man. I think the whole Windows XP thing is super cool. I've been really enjoying it. Okay, so continuous space, right? This is where we're at. Kernel radius R. Now it's radius R. Still rectangular in shape. As R approaches infinity, the space becomes continuous. You can change R, right? So R is our kernel right now. And their growth function isn't continuous yet. A ring kernel, that's basically what we have. But ours is more, complicated because we have weights throughout it. It's the same donut shape though. the smooth kernel. So this is kind of where we're at right now. Ours doesn't look that cool because we're not that cool, but you know, that is what it is. And then smooth growth. So this is where we are with this bell function, right? Which is exactly what we have there. So the M and the S. For them, they do M and S is 1.35 and 0.015. So let's test that out. This is what that looks like, which is, I mean, what I made last time in the last time I implemented this. So they do 0.0135 and 0.015, I believe. I forgot it immediately. Yeah, exactly. Okay, it's not moving at all. I remember the time step actually matters quite a bit, but yeah, it looks completely stable, which kind of sucks, but yeah. Yeah, I mean, it's hard to do this in 3D space and then be like, you know, this is... I don't know if this actually translates well into 3D space, which is something that I didn't really consider before I did the project, which I probably should have, but... yeah, I was like, man, Lenny in 3D space is going to be so cool. I didn't really think, like, oh, it's not going to work. I mean, it does work. It's just kind of, you know. Okay. Well, you know what I'm gonna do? Actually, that's a good point. You know, we should actually just like start facing the thing instead of like not. Like I hate the fact that we have to like turn around. So where do I initialize my camera? Do I have that, I have these in here? Or inside of the camera? Camera here. Yeah, I start yaw at here. It should be here, maybe. Yeah, I did. Yeah, there we go. Okay. Well, so there are two things we could try next. One of them would be to FFT it. Instead of doing our own kernel convolution, we can FFT through it using, you know, and we could therefore get a larger kernel if we FFT it. Now, would that be easy to do? No, it would not be, but it is something that we could do. We can also try adding multiple kernels, which is what we try next. I am going to make this now a variable that we can allocate, and we're just going to allocate into it. It makes you cast the pointers. It does suck, I know. So this is going to be kernel radius times kernel radius times kernel radius. Okay, so we still compile, which is what we were trying to check there. And now during my setup function, we should really get rid of all of this stuff. It's just absolutely not necessary anymore. Down here, we can change the radius to 10 now, and then see what it looks like. Okay. Times R times R. Did I set R to 5? Did I hard code it? No, I didn't. Times grid. An idea why it keeps. Oh, when I exit out of it, that's not seg faulting. When I exit out of it, I press Shift 5 to stop debugging. The reason why is because the threads exit without finishing, since it's multi-threaded. Yeah, but this, I mean, this is seg faulting. So I'll just put a breakpoint there. So like, what is 0, 0, 0 up. This is insane. Wait, what are you talking about? Yo, what's up? How are you? That is bizarre. Because it's at 0, 0, 0. We have a non-garbage pointer inside of grid, and unless grid, what am I doing? I'm working on a 3D implementation of a 2D cellular automata. Like, that is so bizarre. We have a pointer. We have a pointer, but we what? When I set this up, I set radius to 10. Let's try setting it to 5 like it was before. If I set it to 5, it's fine. What do I mean? I like this. It's not finished yet, of course, but it's the idea is here. I have like a isosurface that's meshing it, but we're trying to. What is this? This is it's linear in 3D. Look at the it's Bert Chan's thing that he made. Yeah, so why does 10 not work? Why does 5 work but 10 doesn't? Like, what? Did I hard code 5 somewhere? I don't think I did. Oh, could it be this? Could it be that? Could it be the fact that it's an even number? It's an even number. It might be that. Okay. So okay, yeah, so it's gonna be really slow with a kernel of 10, which is the reason why we they FFT them. But doing an FFT in 3D is probably not the most trivial thing. I'm not really sure how to even do that. I wish I wasn't stupid. I'm not stupid. I just spend all of my time doing this shit. Explain simply. Basically, a cellular automata is like we're generating life with math, right? That's basically what it is. And so this specific one is a generalization of Conway's game of life, which is also a one that was a long time ago, and you know, it's this version is like kernels. Basically, we've got kernels that we're pushing through the scalar fields and convolving like that. I know you were speaking of you. I trust me, I'm not smart. I just spend a lot of time sitting here. What's the font name? It's the fixed sys font in Windows XP. I am the insane chess guy. Lenny, it doesn't have a rule. It does have a rule. The rule is growth. The growth function, which is, it's basically just a generalization of Conway's game of life. That's what we see here. It's kind of like a sigmoid sort of thing. I'll show you what it looks like. It's this function. That's the rule, right? It's underpopulation, overpopulation, but taken into a continuous space. Basically, you know. Okay, so that's the kernel with 10. The annoying thing is yeah, the thing is, so when this is even, we want to do less than, and when it's not, we want to be plus 1. So then maybe this. How about this? We actually should refactor so that we should actually refactor so that this radius is actually radius and not diameter. That's what we should do. It's reversing Via's 2008 executable today for analysis. That's sick. I have no clue how to do that. That sounds awesome. How do I stay motivated? I think YouTube helps me stay motivated, to be honest, knowing that one day I'm going to like make a video or like go live and then show off the cool shit that I'm working on. That helps. I think otherwise, I don't know. I stay motivated because when I'm not focusing on this, then my mind focuses on other not good shit. You know what I mean? So focusing on this means that I don't focus on anything else, which is that's the motivation. Game of Life is made by this guy named Conway, which was a cellular automata, that he made. Look it up on Wikipedia. It's a pretty famous thing. Hey Zombie Man, I'm doing well. Doing well. Is this C++? This is C++, actually. You know, kind of like just C, but kind of C++-ish. Okay, so if we want to make this radius a radius and not a diameter, what are the steps that we would need to take? Okay, so R is going to be... Okay, so let's just start by actually iterating negative R to positive R. Okay, let's start actually iterating that. And we want to now... Yeah. Because it's not radius times 2. It's got to be radius times 2 plus 1. Okay, so let's just do that. Game of life is discrete linear. Yeah, pretty much. Like my glasses, thanks. Don't know except the names. I mean, that's fine. I think Game of Life is pretty awesome, for sure. So I think it's just times 2 plus 1. And then we can just do that. It should always be times 2 plus 1, right? Because if it's 4, yeah, you're always gonna have 1 in the middle. So that makes sense completely. Okay, but now we need to change this. So this will always be D. Yeah, that will always be D. And down here, when we're debug printing it out, we're not going to be going by kernel radius. We're just going to go by D for the diameter. And what this is going to allow us to do is to never have to worry about if we have an odd number on our radius or not, because now we're deriving the radius separately from the diameter. That's what's going to happen. So now our radius of 5 is actually 5. The tricky thing is when we're iterating this here. So we're not going to do radius divided by 2 anymore. We're just going to go minus the radius. This, and then this, and that will, at 0, it is 0. So that's the middle. How is your Windows XP not getting infected? Because I don't have it on the internet. Because yes, I am missing Helix keybinds. Yeah. The best thing about Windows XP is that you don't have to deal with the internet. I hate the internet. I mean, just kidding. Kind of. Okay, so let's define the diameter. We can also cache it, but just use firewall. I feel like on Windows XP you kind of can't at this point. It's just that unsafe. So this is going to be... We will make it more efficient later, but the best way to make it efficient, to be honest, is to probably FFT it. I don't know how to FFT in 3D though. So we might actually have to try and get FFTW on like a flash drive. I didn't really... Okay. It is laggy. It is laggy because we're using a very big kernel, but I did successfully refactor it. Yeah, our kernel is huge because it's a radius of 5 now. So that means a 10 by 10. So a 3 by 3 kernel is more sensible, I think. For if we're doing a kernel that's Yeah. Okay, so we have an actual kernel radius. It's not, you know, bad anymore. Okay, so that's that. Now what though? Now what indeed? 3D Furia needs CUDA to run reasonably. Let's see. Yeah, we have. Yeah, it is multi-threaded. It is 4 threads right now. We can scale it up to 8. I just don't know if it would be worth it. At all. But yeah, there are no bugs anymore with the multi-threading. What I ended up doing was I literally just have a flag that gets set for the done. What was the issue? There was really no issue. The issue was that we were pausing everything to wait for multiple objects. Now I just have a flag that's set on all of the thread data that says if we're done or not. And then so we don't ever have to wait at all, because once we're done, we're done. That's what happens. Okay. Yeah, I don't know if we're ever going to be able to do it with, you know, bigger kernels. But that's how Linea ends up being. Well, you know, kind of, right? Is that you end up with kernels that are the size of the entire grid, basically. But yeah. I wonder if FFT, I mean, FFT has to be faster than not FFTing it. It has to be. It has to be faster than just like brute forcing it. There's like no way that it isn't. How did I get the idea to do Linea? Because I had done it in 2D, and then I was like, you know, I already had done it in 2D, and I always wanted to do something more with it. And then I realized, oh, nobody had done it in 3D, so I was like, why not? Why not try it? Oh, right. This is... Oh, no. Yeah. No, yeah. The FFT thing, it makes the math a bit different, so that's what was confusing me. I'm looking here on the thing here. Yeah, so the kernel is what's being changed here. The kernel is what has multiple rings, so I'm trying to figure out how to calculate that again. What is B here? What is B? B is an array of B. Is there a way for me to, like, see what bro is talking about? What is that? Oh, sorry, I can't read chat. Alright, peace out. Yeah, I mean Fourier, yeah, that's what I'm looking at right here. Well, I'm not looking at Fourier. I'm just trying to find what this is. Can I see what the what B is? New parameter kernel peaks. But what is it? I don't remember how to do it. Do they have I'm trying to remember how I source and GitHub. Okay, but what is the I want to know what is inside of that B array. It's actually like just 3 values from what I remember. It's 1 value for each of the rings. But they don't give you what it is. Maybe they give it at the bottom. I don't understand how Google Colab works. Okay, well, yeah, that's just his Twitter. I remember that there was a way for me to like. Oh wait, hold on. B is not defined. Bro. Okay, well, you know what? That is what it is. I think that honestly, it's just literally an array. What would FFT be used here? FFT is basically doing exactly what we're doing by hand, in terms of like convolving a kernel. If you FFT it, it's basically just a kernel over the entire span, right? I want to see how I found betas. Inside of, I have a function called init kernel here, or reset kernel. Somewhere. Okay, I guess never mind. Okay, so that's what it is. So B is a array of peaks. So that's what was confusing me earlier. B is an array of peaks. So if we want to put B on the kernel, then this is going to be float B 3. Okay, we can have B, and then beta size is how many B's there are, how many rings there are. I think that that's what it is. Okay, so now let's go back to what we did on the initialization of the kernel and try and figure out how to slot that in again. So that's what this was it's divided by beta size divided by the RA, and I do not remember what the RA actually does, but we can play around with it. And so beta size is the amount of, different rings we have. So if we have a beta size, this should actually be an integer. And so let's make that an integer in here. So let's have an int beta size. It tells us how many rings. Okay, so let's see here. So if dist is, so this is how we do it. So if our distance, if our Euclidean distance is less than the beta size, that is a bit confusing though, because we get it into the correct slot here. So if our distance is less than the beta size, then we get into here, and then our final is the beta index, where index is the floor f of dist, but the min of floor of dist, and beta size -1, because we have to clamp it to figure out which ring we are inside of. That's what that is doing. Okay, and then this is 0.5, 0.15. That's a constant that always stays like that. And if I did all of that correctly, this should work. If I did all of that correctly, that should work. Theoretically. Okay, so we have an issue here. Oh, I didn't have that. I also need to go to where we initialize the kernel in terms of the parameters and fix that. I need to go kernel dot, oh yeah, so beta size equals 3. So we'll have 3 rings. And then we set up the betas. I don't know what it should be. Dot b 0 will equal 1. This is what I was trying to look at to see what theirs were, but I don't know what theirs are. Let's try 0.5. 0.2. Okay. So those are the rings. Okay, so we have some more compile errors. We don't have that there. Some more compile errors. Oh. Radius, undeclared identifier. That is true. You do have me there. Beta, undeclared identifier. Oh, whoops. Oh, yeah, I didn't do... Yeah, I'm just being stupid right now. Version from float to int. Yeah, this was being weird before. Okay, and now this is being weird. Beta, undeclared identifier. Okay, so this is going to be kernel B. B of index. Okay. Okay. Okay, let me see what RA is. What do I set RA to? One. Let's try 0.5 F. Yeah, it is kind of just the same. It is kind of just the same. Yeah, I think our thing is pretty much exactly what they have. Yeah, I mean, I think our arguments are pretty much the same. It's 0.15, 0.0, no, this is 0.015 actually. But yeah, now there's no movement at all. I mean, there is, but it's incredibly minimal. You know what? I kind of would be interested. What's this being Terry Davis speedrun? That's pretty funny. You know, somebody yesterday was like, Terry Davis died for this. That's what he said. So I'm glad that you think that, because I love Terry Davis. Actually, you know what? This is actually supposed to be like this. Or not. Or not. Or not. Yeah, no, yeah. Yeah, no, not that. Yeah, the way they do it is that they... Yeah, you're supposed to do... Yeah, I'm wrong, yeah. You're supposed to do it the other way. I was right. Yeah. Maybe this won't work in 3D. I'm not really sure. Kind of sucks though. If not, I wonder. Can I do this? I want to see it in wireframe. I think that would be really fun. I don't mind walking. I don't want to do that now. Yeah, let's try to render it wireframe. I need to remember what the command is to do that though. But yeah, next I guess is different kernels. I mean, I have the beta kernel, but it's hard to really tell if it's doing anything, you know, because of the way it is. I mean, we could try like 0 0.5, 0 0.1.0, 0 0.5, just like that. Yeah. It is kind of sucky. Yeah. uh, man. I really wanted this to work in like 3D and be like super cool, but I'm not really sure. I'm not really sure. It's also like Linea is one of these things where there's just, you know, it's one of these things where you usually have to like load in these creatures anyway. It's kind of hard to generate them yourself unless we like actually write like code that tries to determine that stuff. So it's kind of hard to even know. Hey, what's up, Luke? I'm doing well. I am doing well. Oh, it was so close there. So close. It was so close. It was so close, but then it died before we could get anything happening. It was very close, though. Whatever. I want to see how we do D3D wireframe. How do I do it? Okay, so we can do apparently there's this, D3D or S wireframe that we can do here. Device set render state D3 DRS fill mode D3D fill wireframe. Oh, cool. That's cool. I think about that, it would be a cool screensaver. It would. It would. Yeah, I know the old pipes. I think that this has pipes, actually. I think this has pipes. I have Starfield pipes. There. This does have pipes. Are you interested in creating a temple? No. No. But this room is my temple, that's for sure. That is for sure. If one thing I know, then it's that, Okay. Well, so the next step in Linea, if we're not going to FFT, if we want to skip FFT, is to do multiple channels and multiple kernels. multiple kernels is the thing we have to do first, right? I forget exactly. I forget exactly how this works. Yeah, I'm gonna have to read this and sit here and read it for a while. So this is let's have a little bit of fun here and read it. Um, so so I don't think we have to worry about U because this is for FFTs, and if we're not doing FFTs. Growth of UKMKS. Oh, right. So every kernel has its own MNS. So that's what we have to do next. Right. So U would be us collecting the weighted, neighbor sums, right? And so then we use the growth function. And then we take the mean of all of the G's for each cell. Take the mean of all of the G's. Okay, got it. Got it. Okay, so we get the weighted neighbor sums U. Then we pop it into the growth function for each kernel's parameters. And then at the end of all of it, we iterate through the entire array and then take the means of all of the G's to get the growth step. Word. Got it. Okay, that's not like the most painful thing in existence. It is going to be a pain, but yeah. Have I tried Temple OS? No, I haven't. I think I would like it a lot, though. My guy just shit on my React career. I don't know, man. Do people still contribute to it? Yeah, that's pretty sick. I didn't know that people do, but I think Temple OS is so sick. I made that. Yo, what's up, Appetite? Yeah, I think yeah. Imagine how poorly this is gonna run once we get multiple kernels in here, but that is the next logical step. So let's do that. So we already have a struct for a kernel, and now we just need to expand that into an array. I'm just going to keep a global array of kernels. Yeah, let's just basically make it to a define of max kernels so that we don't overcomplicate this right away. Define max kernels 12, and so let's keep let's extern the kernels in an array this time. To max. Okay. Watching how Terry would navigate through it was always so confusing to me. Yeah, it is his kind of own, the way he does it. It's also so cool the way he like navigates it. And, like it's kind of incredible how he would search his files. I have no idea about why I'm watching this. It's ridiculous and interesting and fun to watch, but as a statistician, I understand nothing. Oh, it's similar to statistics, actually. In some way, the math that's going on here is we're doing a lot of means and we're taking a lot of you know, averages and all that, you know, that's basically what's happening. So for each kernel that we init, right, we want to have a kernel count. So let's also have an extern for that. It's just going to be k count. I think that we already have a k count, actually. Whatever. Okay, so that's going to be kernel count is 0, and then where I go and initialize things, I'm just literally going to have it here, and we will hard code a few kernels, I think. So, or do we want to do that? Yeah, I mean, that's kind of the only way to do it now. So this is going to be kernels 0. Zero all the way down. Okay, and then we init kernel for the kernel 0. Okay, so that should work fine. Now, what isn't going to work fine though is everything in here. So this is now going to have to loop through all of our kernels, right? Which is painful. I should put on music, sorry. Yeah, this is the best one. TurboTax locations are now open in my neighborhood. No thanks. Okay. So d equals kernel.radius. So this is all going to have to be wrapped up in a loop. Maybe we should make this a different step though then. Yeah, so let's do that. So let's have a function that we don't need the weighted neighbor sums different separate, because we can just use the growth, right? Yeah, because we aren't using FFTs, so it isn't necessary. Although technically we should. Yeah, let's just do it separately. So, okay, so, I don't really know what to call it. It's just the main simulation step. So we're going to need to have two buffers that are going to be this, which we will calc. We have to cast a pointer to. Can someone please explain the difference between C++ and C#? I don't really know if I'd consider C# derived from C. It's a very different language than C. I think it's garbage collected now. Maybe it isn't. Maybe it isn't. I don't know much about it, but yeah. I hear that it's like pretty much used for game development on Windows. So yeah. So yeah, all we needed is this, and then this for this is going to be G as well. It's the growth. C# was initially Java. Yeah, exactly. So now we'll just convolve with, we'll pass in U, G, and a kernel, right? So this will just be looping through all the kernels. Okay, we're gonna convolve, but we also have to pass in the kernel, so kernels. So So basically what this is doing is it's giving us the weighted neighbor sums and etc. We're just going to drop everything okay. So yeah, that's what I was gonna do. Okay, so actually, yeah, call it kernel because our namespace for K I think is like polluted somehow. I forgot. So basically, this is actually just doing exactly what this is. It's doing the exact thing. It is literally, so we are just looping through the entire grid and then convolving. Where's A? U and G is what they call it. This is the weighted neighbor sums and the growth. So K count doesn't. We can derive K count itself later. It's not necessary. So N. So this is going to be U at the index of IDX, which is this, right? So we're adding this into U, and then we'll compute. We don't necessarily have to compute G separately, but yeah, I think we have them in different arrays because we're doing Conway's Game of Life. This is linear, so it's a generalization of it. Yeah, so we don't actually need this. Where do we use KZ? And yeah, this is where it is. So that's completely fine. Let's make sure our D. I have D. I have it here. I've seen it invite me to. All right, peace out, man. Thanks for stopping by. So this is this. All of these need to be changed into pointers. Okay. Maybe there is a reason nobody did this in 3D. Yeah, I don't think that it's going to be mathematically possible, but whatever. Okay, so we are putting it on U. Oh, we do have to do it separately, actually. So let's just do that then. So let's make it a separate step, and let's just do actually, hold on a second. Each kernel needs its own U and G. Yeah. What am I creating? I'm creating a 3D version of Lenia, which is a generalization of Conway's Game of Life. Okay, so I need to have... Right, so these are arrays. So I need... Yeah. This is annoying. This is a lot of allocating, but whatever. We need to allocate these in a loop, actually. Actually, we can just allocate it here before we convolve. Is this like a personal project or something? What led you to start developing this? I have a YouTube channel, so this is kind of just what I do, you know? Because I mean, what else am I gonna do, right, with my life? Why not? Fuck it, man. Yeah. So that's that, and then we're just gonna have the same thing for G. And yeah. So this is going to be the convolve, and now we want to compute the growth with G, and this is going to be UI. We also are going to need the kernel for this. Okay. And then inside of here, it's kind of fucked up that, you know, we're going to have to free all of these, and it's probably going to be, you know, sucky, but whatever. Okay, so we could also, like, reuse it technically and just, like, you know, just have these arrays that are, you know, permanently, you know, there, but whatever. So, we just want to literally loop through, so we want GI to equal since on GitHub, not yet. It probably will be. Expected non-alias, very thin font. Why that? This, I mean, this isn't aliased very muchly. At least on my screen. I like this font though. It's hard for me to read thin fonts. I like you know, the thicker fonts. Yeah, so we want to do Bell with right, we need you. Like, what am I thinking here? So I need you. And then just the kernel M and kernel S. I have to make that a thing on the struct. It's a joke of XP, like the talking paperclip. Yeah, Clippy. Yeah, I don't have Clippy because I don't have Office. But I've got, like, you know, the dog and stuff, and the pinball game and all that, and the pipe screensaver and all that stuff. And it is not a virtual machine. In fact, I mean, it's kind of like a joke, but I maybe it is a joke, but I do. My joke is that any application I make on here, I'm gonna make sure that you have to actually have Windows XP and not a virtual machine. Play around on stream? Sure. Sure. I don't want anybody to leave because I'm playing pinball, dude. Alright, let's get to pinball. Where the hell is this, dude? Okay, you know what? I have it on my desktop. Okay, yeah, I don't remember the controls. They're gonna have to tell me about it. Player controls. Okay, so we got. Okay, that makes sense. Yeah, the table bump. I never knew about this when I was a kid, but then I saw it here, and then I was like, what? Like, I never knew that. Yeah, you can bump it like that. Like, what? That's crazy. Am I a student? Okay, it says tilt, and I'm on tilt. Am I a student? No. I was a student once, believe it or not. I'm kind of cracked at this, though. Is kind of the thing. Yeah, I don't know why. I think it said like, it said tilt. Dude, I'm cracked though. I was playing this the other day and I got like a fucking insane score. I don't know how. Yeah, this was my childhood, bro. Yeah, I had the computer lab when I was a kid too. Dude, I'm cracked or what? Oh, come on. Gotta get it into the tube on the right. Okay. That's a disaster. So what is a high score? Or are the numbers just big in this game? Are planning how to learn how the kernel works? Like in terms of like what kernel? Like the Linux kernel? What is hidden test? Okay, I lost. Okay, see, I got 500,000 the other day though. So, what is hidden test? I suck at kernels, unless they're kernels like this. Type hidden test inside pinball? What? That's crazy. Is this a real thing? Okay, I tried it. I don't have anything. I think you're baiting me. I think you're baiting me. No, you're baiting me. That's not real. Cursor needs to be inside. I am inside. Is there a space? Bro, you're so capping. I have tried with the space. I'm trying with capital letters. I'm trying. Okay, yeah, you Google. I'm going to program. Okay, it's not in render. What I'm looking for isn't in render. I'm looking for this value. 0.135 and 0.005. Okay, so that's our first M and our S there. Okay, so all we want to do is we want to compute the growth now. We compute the growth, and if I'm correct, that's how that works. I don't think that I need to do anything else with it. If I'm not FFTing, I don't need to center the value. Yeah. I also have an H value, which is interesting, but that's also a part of the kernel thing that you can have like an H value. So let's just have that as well. And that's what this gets multiplied by. But usually it's just set to 1. Okay. Are you gonna program Space Cadet next? Yeah, that could be interesting. That could be cool. Open Windows 3D Pinball. Hidden test. Okay. No. This is complete lie. Open Windows 3D Pinball. Type in hidden test. Step 1. Open Windows 3. So do I need to close it? Oh shit! Oh shit! Nah, no way. Yo, you're so... Okay, I did not know. You have to click. You have to click it. You have to click it. Dude, this is crazy. What? What? That's crazy, man. That is crazy. That is crazy. Bro, you can just go straight into wormhole. Oh, man, this is crazy. How did you find that, though? How did you find that? Who told you about this back in the day? There was no internet, man, to figure that out. Or, well, I mean, there was, but... It's not like... I mean, didn't have a computer that I could just Google shit on. The only computers... I mean, back in that day for me, were at school. All right, well that's really cool. I didn't know that was a thing. Yeah, that's cool. Ball knowledge. Yeah, I guess so. The way I did this last time was that I did all the kernels at once for each step. I don't think it's necessary, though. Okay, so once you have all the kernels done, then you iterate through the grid again. We iterate through the grid here, and then we, how do we do this? I have to take the mean for all of the kernels. That's a float, buddy. Do you have to do this? No. You just do this, right? Wait, no, it isn't I, it's K-I. And then you go divide by the kernel count. Okay, and now it should be this. We just do this. We just do this. And now we don't even need a back buffer. We just do this. If we want to be super efficient about it, we don't need a back buffer anymore. Or actually, we kind of do. And we are going to need to do this still. And now at the end, all we have to do is we have to loop through all of this and then just free it. Okay. Oh, you did. Is this your first time on Linux, Luke? That's sick. I'm glad you're enjoying it. Here we divided n divided by k count. I wonder if we have to do something similar here that I forgot. Yeah, we do. Isn't it down here? God, I don't know what fucking... It's gotta be outside of here, right? Good dev, thanks. Do we risk to have screen tearing without a back buffer? It's not the back buffer, it's a back buffer for the actual scalar field. Yeah, I don't remember, like, this is nested so many times, man. Like, don't ask me where this shit is. Okay, it's outside of here, no doubt. U IDX divided by the K count. There we go. Good dev, thanks. Maybe I responded to that already. I don't know. Okay. I'm ready to click the delete button. Get fucking rid of it. Okay. So we do also need the D, don't we? It only matters for this, and we have the thing for that. Yeah. Okay. I've used Arch and Archbase, but I really didn't like neatly days in config and CSS files. I get the hype. Yeah. Yeah, I recommend to use Sway for sure. Sway is a lot of fun. I definitely wouldn't recommend doing a Hyperland. I think Hyperland is cool for like the artistic aspect of it, but it's not like usable, to be honest. It's my favorite distribution. I like Arch and EndeavourOS. You know, it's cool. I mean, to be honest, every Linux distribution is like exactly the same. If I'm being honest with you, like they're all the same. Like at the end of the day, it's just like choosing your favorite flavor of ice cream. You know, like shit's kind of the same. You know, like sure I like vanilla more than the others, but if you gave me chocolate, it wouldn't be like, oh my god, it's the end of the world. Like, there isn't like a flavor of ice cream that I'm like, oh yeah, that shit is disgusting, man. It's like it's all the same, kind of. That's also the problem that I have with it, though. I wish that there were things that were like weird distributions, or like, you know, it just doesn't. That doesn't exist, you know. Okay, I have no clue if this is going to work, but I think we just have to send it. Okay, well, let's see if we Okay, we have 2 errors, which is a lot less than I thought we would have. Conversion from double to float. Possible loss of data. Okay. Say it, don't spray it, bro. What is the problem? Like, double the float. Like, okay. Function or variable might be unsafe. You're fucking unsafe. You're unsafe, bro. Everything you do is unsafe. This is a float. Oh, no, it isn't a float. Never mind. Function does not take 2 arguments. Okay. Well, you're right about that one. You got me there. Okay, we got it said 2 errors, but then it's like, okay, actually 10 errors. Okay, we don't have anything. Okay, well, mess it up. How much I roast my code off screen? There are some times where I'm just like, yeah, that's cursed, man. For the past few hours, I've been watching you on a screen while trying to work for myself. My attention wanders so quickly. How do I manage to work consistently and stay focused? Has nothing to do with what you're doing right now, but I wanted to ask. I stay focused because I think streaming helps. 1, 2. Oh, I never set kernel count to non-zero. That's what this is. 2, I have ADHD, so it helps when I stay focused. How I end up staying focused is see, when I'm not focused, I'm thinking about bad things. So for me to, not think about bad things, I have to stay focused. So that's how I do it. That is how I do it. Well, the things these streams are teaching me is that I need to brush up on my maths. Yeah, I mean, not really. Do I vibe code much? No, I do not. I do not. Am I okay? I'm alright. I'm alright. Okay, so now we can add more than 1 kernel. That's what that just proved to me. That just proved to me that we can work on. So let's get rid of the wireframe. Okay, so now we can do more than 1 kernel. So let's do another kernel with different... let's make it a radius of 5 and a beta size of 2 and get rid of the last one and make that a 3 and make that a 1.0 and make that 0.5. I don't know, man. I'm just doing shit. What are my opinions on vibe coding? Well, here's what I think about vibe coding. I get sometimes these things in my recommendations, like it's this guy that's like sitting there in front of a whiteboard with like sunglasses and he's saying like, and the title is like, vibe coding every day until I make $1 billion. He's got like a watch on and he's like sitting there with like 10 Claude codes open and he's just scrolling shit and then typing shit and scrolling shit and then I've got kind of like I've got a piece of advice for you in terms of like life, man. When you see somebody who looks like a douche doing something, it's probably because that's a thing that douchebags do. Yes. So that's what I think about vibe coding. Did I get an actual ADHD diagnosis? Yes. diagnosed with many things, including ADHD, and I take medication for it. Does anyone listen to music while focusing? Yeah, tell me about it. I gotta put that shit on. Windows 2K? When are they gonna bring Windows 4K? Okay, so it is working, but the simulation step is now 20. I feel like vibe coding has helped a lot of people get their POC out there. People of color? I don't know what the POC is. It stands for. I think it's I don't know. Proof of concept? Oh, yeah, that makes sense. I mean, I guess so. You know, I feel like this misconception, you know, that I might be like jealous of like the success of people that use AI or something, or that I'm worried about my job or whatever. I'm not. I just think like I see shit like that and it's like, man, it's like we've like as humanity has like made so many beautiful things, and now we just are okay with making shitty things. That's all I think about it. Like things that are vibe coded or like created by AI, it's just regurgitated Stack Overflow code at the end of the day. It's like not actually. So I like have like a kind of a problem with it, I guess. Oh yeah, this beta is way too. Yeah, AI will never replace, you know, but I don't think that the technology is there, but greedy bosses will definitely lay people off because they're like, we can get away with it because we now have Claude Code or whatever, you know? So just because the technology isn't there doesn't mean that people aren't going to lose their jobs over it. It absolutely will happen, and it is happening already. Still designing my programs because I really don't want technical debt. Glad you could write code for your projects. Oh, thanks. I don't really get the whole technical debt thing, you know? You just keep coding and then keeps coding and then, you know. So it is working. It is kind of inefficient though, but, you know. Yeah, so we do have 2 kernels officially. I think so. Drone music is awesome, yeah. Drone music is sick. I'm trying to think, like, what are my favorite drone pieces? It's hard to really remember. I guess, like, drone-ish ambient, definitely. Vibe coding to me is comparable to that one feature that VS Code has that auto-completes code based on... Oh, you're talking about GitHub Copilot? I'd argue that it's definitely not like that. Like, the people that I see using it are actually just like people who don't know how to code. Like the people who like call themselves vibe coders or whatever on the internet, people who genuinely don't know how to code, right? If you use like an LLM to like talk your ideas through or something like that, I think like that's probably an acceptable way of using it. I think it's acceptable because we live in a world where human communication isn't a thing anymore. So that's why I think that talking to an LLM is probably acceptable to some degree. What I don't think, I see most people using it, people that don't know how to code, or trying to make up for the fact that they don't know how to code with it, and that I definitely have a problem with. I don't think I had a problem with it all the time, but I think more and more I've started to have a problem with it because I don't know. It's like It's just kind of like sad, man. Like, I don't know. I program because I'm like passionate about it, right? And so I'm obviously like passionate about, about it in the other sense, But yeah. Now I'm wondering if this kernel radius is going correctly. It's 3, 0. Yeah. No, maybe not. When I generate it, do I... Yeah, let's print this out again. I want to make sure that I... Well, it is kind of interesting to see that it's a literal... I don't think so. I mean, I've tried these technologies as well. It's not that I'm just like sitting here and being like, I've, like it leads to a uniformity of code. Do you understand what I'm saying? Like, if I write the code, I know that it's my vision, right? Like, I know that I did it this way because it's my understanding of the subject matter. It's exactly how I wanted to make it, right? Using an LLM to give yourself, direct code that you can just like pop in, right? It is completely defeating the purpose of making something yourself. It is completely. Just because you might think that it's like some sort of like shortcut or something like that, I completely disagree with that. It is not just a shortcut to get the code. That's not a shortcut. That's just you didn't do it. You get what I'm saying? That's just you didn't do it. So I mean, but maybe I'm crazy, but okay, so this is incorrect because of the beta thing. Yeah, I think that this is... But, I mean, to be honest, like, in the past, I just usually say, like, I don't have an opinion on it. When people ask me, like, what do I think about vibe coding, or do I ever vibe code, I usually just don't say anything, because it's, like, for some reason, like, a sore point for people, even though I don't think that it should be. It's like, Do I remember Cleverbot? I do remember Cleverbot. I remember, like, my friends and I, like, sitting around, talking to it. This is funny. This is less than R. I think that this is incorrect, man. I think that I transcribed this from the rest of my code incorrectly. I think I transcribed it incorrectly. R is less than radius. Yeah, that's weird. If this is less than radius, that's exactly what I have over here. You know, maybe this is actually how these are supposed to look. Alright, peace out, Luke. Have a good night. Real question. Do you use C++ with this VS version because of no declare anywhere? If you use C. Yeah, pretty much. Yeah. The C89C compiling on this thing is disgusting. Yeah, absolutely. The fuck is happening? I'm, trying to figure out this kernel stuff. What do you think about other gen AI like image video? Invest talent into development of any of those. I think that in the right hands, those technologies are really interesting. Like, I think that those technologies are like actually incredible. The fact that you're able to do that stuff nowadays, like, it's genuinely insane technology. Now, do I think that the technology is safe in a world where historically we use new technological advancements to take advantage of people? No, I don't think so. And I think that that's the problem with it, that I have with AI in general, is that the technology is dangerous, and I know that it will be used to make rich people more rich. That's the problem I have with it at the end of the day, just as a whole. But yeah. Don't think that there's a good thing which has come out of it. Yeah, I mean, I guess so, but the conceptually, right, the technology could be used, right, to do, incredible like works of art, right? If there was, human involvement in it whatsoever, but yeah, I mean, I don't know. Like, I think being an AI artist, right, is like you now just feeding it a prompt, It's like imagine if we had AI artists that were actually like building neural networks, like this guy in the Discord that just made this neural network that takes, a picture and then takes another picture and then makes it into the style of that other picture, right, artistically, right? Like, he like feeds it like album covers and then like translates these comic book pages into the style of the art of that album cover. Like, that shit is awesome. That is like so cool what I was looking at. Like, that was like incredible for me to see. Stuff like that. Is that just a Laura? I'm not sure what that is. But I mean, he is like a student, and he made it himself. But I think that stuff is so cool. It's just that is so sick. Yeah, AI could be used to make like crazy things right now, but it's not. It's kind of just not. It's kind of just like making, slop, like. But the thing is, most people just watch slop anyway. That's kind of the problem in the first place, is that everybody just like watches shitty fucking Jake Paul videos on YouTube all the time. Like, of course, that's what the AI is going to represent, Yeah. Okay, so we have multiple kernels now. We're only one step away from having multiple channels, which is the next thing. So Yeah, so let's read through this. I don't really remember what exactly this is doing. Yeah, maybe I'm not thinking correctly what generative AI is, but yeah. All the like the videos I've seen of like people just like, you know, typing in a prompt and then, you know, just creating slop is, yeah, definitely stupid. Okay, so we already have this, and H is what I think it is. Maybe not. No. I forget how this works. I think I might have to look at my own code, my old code. I think each channel might have its own kernels. I think that might be what it is. I think it may be like another dimension like that. Peak brain rot? Bro, just get a GF. For example, I found it interesting when they... Yeah, like that stuff is really sick. That stuff is really sick. Sleep or skip class in the morning? I think personally you should sleep if you want to, you know, excel at school. But I mean, if you don't want to excel at school, then, you know, that's your prerogative. I also chose to not excel at school, so I can't really judge you for it. I can't believe that you would say that this is brain rot. That's such a funny thing. This is like the opposite of brain rot. This is me like doing math. Like what? Brain rot. Brain rot. So this kernel C1. Yeah, I forgot how... So we have, if channels are greater than 1, and then we're looping through all of the channels. And then we loop through all the G's and the... For each channel, but where are we using the channel count ever? Oh, HI. What is HI used for? Is it used here? It is used here. HI times the time step. And a soft clip, hard clip it. So, okay. If I equals C1. Oh, right. Right. I'm sorry. Go for attendance. We have to learn everything via YouTube. Yeah, that does suck. I hate teachers too. Trust me. I'm not a big teacher fan. Teachers teachers are not the craziest fan of me either. Wait. Okay, so kernels, okay. So let's remember what this does. So kernels have an C0 and a C1. Okay, C0 is the input channel. All right, peace out. Have a nice night. Good luck in class tomorrow. And then this is the output channel. And so the input channel is what feeds into this kernel. I'm trying to figure out how that part works, though. When we apply kernels, compute products worker, I have this function, and it uses the if it's product sells I. Oh shit, hold on a second. Product sells I. Oh shit. Channels output forward. Okay. Okay. Oh, fuck. Okay, now I'm realizing why this is really annoying. Oh my god. Okay. Okay. Okay, so now I remember why this is really annoying. Okay, so we now need different cell grids per channel. Right. Yeah, I remember why this was interesting. This gets interesting. This does get interesting. So now we have the back buffer and the front buffer, right? But now we need, this is an array to max channels. So it's adding yet another dimension onto it. Yeah, it took me a while to figure out, but whatever. I had to read my code back, and for now let's just leave it at 6, or else it's gonna get like ridiculously big, but okay. I should get another coffee soon, so I may take a break. Can I find all references? Okay, well that's not all the references. Oh, here it is. I need to go to where we set it up in here. Where do I allocate this? Oh, here I allocate it. Okay, so Yeah, this is the interesting part. So now we have to... I'm just going to allocate them once, and then we'll just never think about it again. Because that's the way it goes. Yeah, let's just allocate it once and not think about it. Yeah, sorry, I just zoned out. Yeah, this might be a coffee time thing. So yeah, we're gonna have all these channels, and then so the kernels are going to have an input and an output channel, which is literally the version of the grid that they're outputting to, right? So C0 will equal let's just do the so let's just say that they're outputting to the same channel for now. They're just all going to channel 0. And then what's going to happen later is that we're going to have different channels with different colors. Windows XP is too old and outdated. Okay. Facts. Well, you know, so is like Citizen Kane and Casablanca. I think a lot of good music. I think Bach is super old and outdated. I think, you know, I don't even like Pulp Fiction, but Pulp Fiction is just incredibly old and outdated. I get the nostalgia for old culture stuff. It isn't old culture stuff. It's art. It's art. Somebody cared about this. Somebody made it. You know, it has an identity. It has a, you know, somebody cared about this thing. You know, modern Windows, no one cares about. No one gives a shit about it. Modern Windows steals your data. Modern Windows is spyware. Like, you know, whatever, man. You do you. Yeah, man, I like programming like people used to, because programming nowadays sucks. So, but you know, they do though. The design is more user friendly than older Windows. The design of this is very user friendly, extremely user friendly. In fact, some might argue it's too user friendly. Look, for example, let's take a look at the buttons on the top right of a window. We have the minimize, the maximize, and the X button. Do you see how they are actually real? Like, do you understand how this goes to the bottom left because it goes to the bottom left? This has a genuine, like, artistic, you know, quality to it, that now it's just abstracted away as, like, you know, a square, a line at the bottom, an X, you know. I don't know. It's like, it's become, you know, minimized into a point where it's just, it's soulless. It's genuinely soulless. Whatever. Yeah, MSN, and more importantly, MSDN. Do you know the fact that they used to have actual documentation that you didn't have to connect to the internet to access? Like, you could actually just sit here not connected to the internet and read it like from a virtual book anything you could code. Do you understand? It's like Bill Gates isn't even involved anymore. I don't give a fuck about Bill Gates. Windows and Microsoft still suck. It has nothing to do with Bill Gates. I mean, he's a pedophile, but it has nothing to do with him. Like, it's just the company is bad, and it steals your data. Literally, to fucking log into your computer, you have to have a Windows account. That's not how software and hardware should be built. It's not. It's absolutely not. But let's agree to disagree. Anyway, so we have to loop through all of our channels and do them separately. For now, let's make an extern just to have our current amount of channels, because that is what we need to know. Let's just call it, yeah, let's call it channels. Why not? And let's keep it at 1 for now. And when we are, well, populating the vertices might actually be problematic, yeah, because we're looking at one. Do we have to do this per channel? Oh, fuck. That's really bad, actually. That is really bad. Oh, man. Yeah, that's... Oh. You know what we might actually end up doing? Yeah, I didn't program when it was MSDN either, but yeah, I remember MSN and yeah, all that. Yeah, the games were so cool, man. Games were very cool, and I love the art, man. Like, look at these screensavers. Some of these are just so cool. It's just so like new agey and interesting, I really love it. The art that went into it. It's kind of incredible, Yeah, so there's one of two options. We could have each thread do a different channel now, or we could just, like, yeah, but then you're kind of capped on the amount of, yeah, you just want to wrap this in channels. That's what you want to do. Yeah, so then the cells that we're looking at are all going to be from a certain channel. Yeah. Encarta. I don't know what Encarta is. I don't know what that is. Should I know what that is? Oh, shit. Oh, no. Just don't think about it too much. Okay. I did I instead of C. The original, a Windows encyclopedia. I have no clue what that is. Was that offline or online? Um, okay. I think that that's actually all we have to do. Offline, but it had online resources. Yeah, I don't even think I have that on this computer, though. Did that come on a CD? I don't think I've ever heard of that. Okay. So, we have to do all of this per channel now. Yeah, I think that that goes per channel too, because I have to... Yeah. So we have a compute products worker. So it all goes separately. Kernel's K, which is the grid, and then the temp K. I'm not sure what temp is. I think temp is possibly the grid. And temp indexed by K. Yeah, I do not remember this. Temp K. I don't even think we have to worry about this because this is FFT stuff in my old code base, so maybe I just don't worry about that. But I still have to do this per... I'm pretty sure that I still have to convolve per channel, unfortunately. Which is not going to be easy. Got it on a not so original CD? Yeah, I'll have to check that out. Okay, so yeah, I think we have to do it all per... I think that this also has to be per... Yeah, I think each thing has to be separate. Each thing has to be completely separate. So maybe I think that this whole entire thing needs to be in a loop. Which is crazy, but I think it does. Yeah, I mean, let's just think about this. So we are going off of our own cell grid. Look like a real hacker. Yeah, you're really getting to me, man. Like what? Okay, so I'm just gonna do this. Yeah, so we'll free it at the end and then reallocate it. It's completely fine. I think the way I probably had it was just like had it literally allocated per channel, but I think that might just be too slow anyway. We're gonna convolve per channel, compute the growth per channel, and then this will be cell C, and then it will go into back C. Oh, but Yeah, that's a lot of mem copying that I have to do after now. I mean, I guess I just have to do it per channel. It's not like the end of the world. Okay. We need to do the same thing at the beginning. I think what I originally did was that I kept these buffers. Yeah, the thing is, back should always equal cells at the end of the update, so you shouldn't need to copy it originally. The only thing you need to do is copy it on initialization when you initialize the field. So that's all I need to do. I don't remember where that is though. Oh, it's here. Okay, so this obviously has to be yeah, so if we want to init it to zeros, then we should just do, yeah, like this, and then just loop it. And now cells, yeah. And you also want back. Okay. Okay, so we need to pass into here the channel. The growth step shouldn't need it, right? Yeah, the growth step doesn't need it, but here it needs. Let's just call it C. Just why not? C. Okay. Is that it? Okay, I'm sure that we're gonna get a bunch of compile errors, but okay, yeah, just get rid of it. Oh. Yeah, this is just, yeah. Okay. So this is still one channel. This is still one channel. The goal, though, is to have different channels have different colors, is how they do it in, how Bert Chan does it. Unfortunately, doing that isn't so easy. When we have this multi-threaded stuff going on, and the fact that our vertices are on one array. Yeah. Also have to yeah, basically, as so if I can show what I'm talking about here, the thing here is that you can see this. So each one of these colors is its own distinct channel, which is basically its own draw buffer, its own cells that it's reading data to and from, its own, its own representation of what's happening here. So that's what I just refactored, was to get it to the point where now we basically have every channel has separate data, completely separate. The issue is now getting color, right? Is like, how do I get color without having 3 different draw buffers, right? How do I do that? I'm not sure how I'm gonna do it. I know that it's possible for me to do it. I know I can do it, but yeah. Yeah, so this is with multiple channels. It is like laggy, right? It's because literally we are just doing double the work is what's happening. We're doing it twice. Because we have 2 different, basically 2 different scalar fields now. Except we, the problem is that we can't represent them separately, just don't have it, the ability to. Did I try Linux? Yes. I'm streaming off of Linux. This is a capture card on this machine. I think colors is going to be sick, though. I don't know how to do it, though. Don't know how to do it. I think we have to stop using a material and use instead garage shading. Per vertex shading. I can do this. So in our vertex thing, right, what we could do is we could also encode color per vertex. Like this. What am I trying to make? I'm making a 3D implementation of a cellular automata named Lenia. This has to be, I don't know what it's called. So like emulating shaders? Not necessarily. I did on the PS1 the same exact thing. It's just per vertex color, and it's going to interpolate it on the GPU itself. It's built into, this is how they used to do it, back in the day. Yeah, you know what, this is, I have to use the MSDN here to find out, or actually, let me just open up the book. It's definitely in here. I just did the example with it the other day. So have to see. Yeah, those were good. I really enjoyed that. The whole portion of that was definitely, like, doing the collision in the movement code was really difficult. But it was crazy because not a lot of people have done that on the PlayStation in terms of like b-hopping and stuff. It was really fun. So this is the color vertex. I need to know. Yeah. Okay, so XYZ. Really? Can you use that again here? I hope so. I don't think that you can. That's not how Zoring works, man. Got a modded PSX, so got I burn this game to a CD? Probably. I mean, I would have to get the... I definitely have the ISO somewhere. I would have to find it. Yeah. I definitely have it on some hard drive. But yeah, I could send it. Hopefully. I did leave it in a usable state, but I mean, it wasn't like a real game. It was just basically a world that you could jump around, you know. It had collision too, yeah. Yeah, this is confusing me. This is really confusing me because they're basically saying that we should have two vertices on top of each other, which I don't think is the example. Let me see what their example is again. Okay, where's the triangle example though? Okay, here it is. Okay. I was about to crash out. I was like, what? Okay, so they do XYZ D3D color diffuse. Oh, okay. So the diffuse color is this. Okay, got it. So this isn't this. It's D3D color. It's like that. And this is diffuse. Yeah. Let me just make sure that we still compile here. We should. Yeah, we do. Okay, good. Okay, nice. Yeah, shut up. Okay. So now that we have that, I need to fill it with values and then use it. We could have each channel just be a color, a certain color, but it's like, yeah, the problem is that we're putting them on one vertex buffer anyway. So we do it for each channel. We go this. Oh, we do it per channel. Oh, so in that case, we could just literally, when we create a vertex, we just literally put it here. The channel color. And then interpolate it later. Okay, that's not too bad. That's not ridiculous. Let's just define these globally though. We're gonna have 3 colors. Actually, yeah, let's just do it like that in the C++ idiomatic way. Using growth mapping. It's similar to that, but it's not. It's what they do. It's similar, but it's not that. Where's the? It's here. This is the formula. It's similar. I think it might be equivalent. It's very, because they also use that one, but I think it's equivalent. Possibly. But yeah. Okay, so then we can just like call it C1, C2, and C3. Right? And so this one is going to be, let's make that one white, and this one red, and then this one blue. Yeah, let's just make it red, green, and blue. Okay. The thing is, we don't actually have them in an array, which it would be nice to have them in an array. It would. Also, these are D3DX colors, not D3D colors. Does that work? I forget if they have the thing operator overload. I don't really know if it is, but I have to put it in the constructor too for this. D3D color. Yeah, I could do a D3DX color, but D3D color C. So let's just call this D3D color, and then just do this. I'm pretty sure that this works syntactically, maybe. Okay, and now we just have to do color dot. Yeah. Okay. So that's that. All we have to do is like literally say if C is 0, then this, and then just like have a D3D color here. Just like that. I should have started at C0. My bad, my bad. It's really complex. Yeah, I mean, the Linea stuff does get pretty complex, to be honest. Once you like start adding different channels. So basically what is going on here is that we have basically now we've different arrays of data, right? That are that you know is like, if you know Conway's Game of Life, it's just different arrays of data, right? Different zeros and ones. For us, it's continuous from 0 to 1, right? In decimals, but we have now here we have 1, 2, 3 of those on top of each other, and they are being updated simultaneously, right? And each channel has its own, you know, set of parameters, right? So that's what makes it crazy. That's what makes it crazy. Okay. So now we just pass in color into here, into the constructor, and we're not going to see anything different. Okay, so this isn't possible. Too many initializers. Do we have to do like D3D color RGB? No, it looks like it's just going to stay mad at me. How did I do this last time? I don't really remember, to be honest. Yeah, XRGB, yeah, but then that goes to an X color. You're the guy who made an entire engine for chess. Yeah, I am. Yeah. I need D3D color is RGB and D3D X color is with alpha channel. So that's why I'm trying to get it to I guess I could just like do this, you know? And that's also fine, but I really what I was trying to avoid doing was to make this define. The doc probably does say something about it, but I just I'm just going for it. Okay, but how do I get this to a D3D X color? A D3D color? Because this is going to get mad at me in the constructor now. Okay, it didn't get mad at me in the constructor. Well, let's just keep a mental note that that might be why it doesn't work later and just move on. Okay. So... yeah, we should probably read. Let's just try to actually get the color on the screen, though, which is what we're trying to do here. So to do that, I think we need to turn on flat shading. I don't remember what the thing is. It should say it in the book. Yeah, we did this. We did this. That's what we did. If I was Curl, I would have a boyfriend like you. We together can ditch Rust devs. I mean, I'm with you on that part. I'm with you on that part. I'm with you on that part for sure. That's funny. Okay, but okay, half of it is red and half of it is not red, which is interesting for sure. I think that they're on top of each other actually. Okay. That was a lot less cool than I thought it would be. Hold on. We're probably doing this wrong, to be honest, but you know. Let's think for a second. Let's think. Okay, what are our colors like? This is green. This is green. So that's green. So there was no green. So okay, first of all, you know what we should do? We should just turn off lighting. Okay, let's just turn off lighting just so that we can see the raw color. Okay, maybe that is green. On the right, on the left, that does seem like green. It is split right down the middle. Yeah, it does seem like green. Okay. So, I'm wondering why half of it is green and half of it isn't green. Technically, nothing should be on the other channel. Oh, well, first of all, we did make a mistake because certain kernels are supposed to be outputting to certain channels, and I never coded that. behavior in. So we have to do that next. Don't remember how to do that though. Hold on. Oh yeah, I think that we literally just do it here. Like if kernels I dot yeah. If the C0 doesn't equal C, which is our input channel, then we continue. Wait. No, I think that we're just supposed to use the input channel. This is supposed to be... Yeah, that's supposed to be C0. What time is it? Holy shit, it's 6 o'clock at night. That's crazy. Yeah, is that it? Do I have any plans? Like a party that I'm going to? No. No, I do not have any plans in terms of a party that I'm going to. That would be awesome. That'd be awesome. Awesome to be young and stupid again. That would be sick. Oh, I got pinged in the Discord. Why don't I have access to that channel? I have to give this guy a Discord role. Sorry. I was... You can always be old and stupid? I guess. I feel like it gets more dangerous, you know, with my heart. For example, my heart is dangerous now. Dude, if I stand up too fast, then I think, you know, it's not a good scene. Dude, I think that this is true, right? I think it's like this, yeah? Because if C at 0 is taking it from there, and then C1, if C1 doesn't equal the output, then we want to, yeah, totally. Okay. What? Well, like, what is the problem? What is K here? K is 1, I is 0. Bro, like, we should... Oh, yeah. I didn't do K. Yeah. What is wrong with me? My bad. I can't stand it out anywhere. Yeah, that's the sign. You look younger, just use dark mode. That's good. Okay, well, this isn't my file. Oh, I know what's happened. I know what happened. We just have to not free it if they don't. Okay, so listen. Okay, I know that it would be more efficient for us to not allocate those. I'm not putting a breakpoint there. Okay, but shut the fuck up, man. Like, what did I do that's wrong? I didn't do anything wrong. I didn't do anything wrong. Like, I'm allocating all of them all the time. I'm allocating all of them all the time. I wonder if I go to 0, is it fine? If I go to 0, it's fine. Do I use Hyperland on Linux? No, I use Sway. I tried Hyperland and then I fucking ran one of those scripts and then I downloaded like 200 fucking things onto my computer and I was like, okay, I'm never using Hyperland again. That was my experience with Hyperland. Fuck, man. How many channels did I do again? I did 2. I did 2 channels. So it should be 0 and 1. Man, I don't know. Like, let's try this. Okay, that's what we want to see. The whole thing is green now. Okay. Actually, that's kind of not what we want to see. Because there... Wait, no, that is kind of what we want to see, but it is strange that that's the case. Because this is the input channel. What was that? The green? Do you want to... The split problem? Oh, yeah, I don't know what the problem is, man. I'm trying to figure it out. So basically, in Lenia, at this part, we have 2 different channels. We have an input channel for each kernel and an output channel for each kernel. The issue we're running into is that for some reason this is breaking when I turn C1 to something else. When I turn C1 to 1, it breaks. Which is bizarre. It is bizarre. Yeah, I'm not really sure. That's kind of annoying. Because if the kernel C1 doesn't equal C, which is what we're looping through, then it should just continue. But like, let me try it on this kernel. Just 1-1. Okay, 1-1 works. Okay. Well, 1-1 works. Okay, and so does 0-1 work? This is what we just tried. Okay, so 0-1 works. The fact that this is giving me a destruction of the heap issue is like pretty scary, but I think it's probably because we're just violently exiting out of the program. Okay, so it seems to be working fine. We're no longer having any issues. We still are green on this side and then red on the other side, but if we look closely, we see that there is green on this side as well. There is green inside of the red. What this means is exactly what I thought it meant, which is we are emitting both on top of each other. And I think it's going to be a pain in the ass to not do that. So... Actually, no, we aren't. So we're doing it per channel. But then why does this not avoid already occupied zones now? No, I think it's a combination of us already having a pretty, you know, a pretty flimsy way of going about it. Yeah, the green side doesn't have any red in it, but the red side has green in it. As you can see, they're separating a bit. The green is separating from the red slowly. Yeah, they are separating. The green is actually staying completely static while the red is dying. So it is slightly working. It is slightly working. I feel like a big part of it is that we didn't really change the parameters as much, like, you know, between them as much as we probably should have. What am I typing? Like two kernels going to two separate things. And it's so weird that the green ends up only on half in the initialization. It's very strange to me. I wonder if it's literally that. If it's on my initialization that's the problem. Okay, well, I'm lagging pretty bad because of this. It's inside this file. No, I initialize it to channels, but I don't. Do I set channels up before? Do I set up channels before I No, I set it up here right away. Which one is green and which one is red? C0 is green. This is C1 is red. Yeah, it probably has something to do with the multi-threading, to be honest. But oh, I know what it is. I know what it is. I know what it is. I figured it out. We need to allocate enough space for multiple. We aren't allocating. We only allocate for one channel. We never allocate this for channels. There we go. Okay, never mind. I lied. I thought I had it. We should really not have also this material or this light if we're doing this. Like, just straight up not have any of this stuff. Okay. Well, never mind, I guess. Do we need lighting to have the shading? No. Does he have any initialization that he does for it? I don't think so. Alright, I wonder why it works with this material and not otherwise. I don't think that we should need a material to... We should just be able to draw a primitive with what is their FVF? Oh, you need to set lighting to false instead of not set it at all. Lighting. Where did I have this? Yeah, here. So turn to false. Okay, there we go. Okay, but this is exactly what we already knew, was that this half of it is green only. And it's annoying because the first the first channel is green, so that means that the first channel is the whole thing. We initialize them to correctness. Oh, you know what it probably is? Oh, maybe it's not that, but you know what? Let's try this anyway. Let's try to explicitly what is the problem? We do have 2 channels. Yeah, the issue is that the green channel obviously appears on the left side, while the right channel does not appear to be on the right side. So if I had to guess, it probably has to do with the multi-threading, maybe. Not entirely sure. But yeah, the multi-threading might be, I don't know. Like this goes through all the channels, does them separately. Oh, you know what? Oh shit. Oh, that's why. That's why. Oh, yeah. Okay, my bad. Yeah, I'm so stupid. Oh, man. Yeah, I'm just being dumb. Yeah, there you go. Yeah, I was just being dumb. I forgot to reset the values at the beginning of a new channel. My bad. Yeah, that's me just being dumb. Okay. We can go back to having like proper shading now. Unfortunately, we can't just do like a different material, but we can do garage shading on top of the material, which is kind of the same. We just have to make sure that it's not tinted any color like this is. Just have to make sure that it's not tinted. So we can just like do this and then bring back the light, which will give us the light again. Yeah, and we just have to make sure that lighting goes to true again. Is it a bit foggy? Yeah, I mean it's washed out because I took the color off of the material, and now I'm just making it completely vertex color. So you can just, it's washed out because this is all 255. Like all of this is 255, so you would have to like go to what, like 128, 127 is what it would be to be completely neutral. But yeah, I think it just won't have the same, like, I don't know. Like, I don't think, I can't put this at 0 and let it just have the vertex color. I don't think that it's possible for me to do that, because then it won't get lit up, is the problem. Like, if I do no material, then it's just going to be dark. So maybe there's some other way that I can do it better, but for now. But yeah, if we're going to use vertex color, it's kind of impossible to shade it properly is the problem. In terms of like having light normal, you know, which kind of sucks. I'm sure that there's a way to do it like within the normals itself, you know, but it's definitely beyond the scope of today. So it's definitely beyond the scope of today. Yeah, but I think you do want lighting, and you do want it to be like, you know, reflecting a bit. But yeah. So anyway, we have the ability to do multiple channels now. So we can set this to channels 3. It's going to go incredibly slow, but we can. And we can do like a thing where we set this to go to this. We can also do like 3 kernels now, right? Let's have a radius of 3, beta size of 2, and make this one go to 7. And then this one goes to 2, 5 with an S of 1, 5 and an H of 1, and then have it go from 2 and feed back into 1, or have it 1 feed to 2. Yeah, I kind of wish you could see through it, and that's why I'll turn on wireframe, just to see what's going on. Okay, well, the wireframe doesn't actually get the different vertex colors, which is kind of annoying. Or it does, but it's like really hard to see it. I wonder if there's a way to make it transparent a little bit. Like, what does a material have on it? You probably do like D3D blend. Whatever, man. Whatever, man. Anyway. Oh yeah, by the way, I totally forgot to do this. This was on the same kernel, so that's why that was. Oh, and I forgot to do kernel count to 3, and then change the to 3. and get rid of the wireframe. Okay. So I mean, yeah. I know this sounds stupid, but this is, yeah, I mean, that's basically Lenia. I mean, I think I have to now just work on making it look better and do better things. I don't really know how to do that. You know, but yeah. I guess it was kind of silly to assume that it would work like super well in a 3D space, but it was a nice attempt. Yeah, it's cool. I do think that like the third channel isn't working properly for whatever reason. It's like maybe we should put them on like that or like what like. Yeah, like the third channel, the blue channel appears to just like take over everything. So I think maybe you just like did something wrong, or maybe this kernel is just ridiculous. Yeah, I wonder why that is. Yeah, well, yeah, I don't know. I'm gonna have to like come back tomorrow whenever I do and try and figure out how I can make this look better, you know? Because yeah, it's not exactly what I want, you know. Um, I think it's neat for sure, but you know, it's not really an automata. It's just kind of a moving blob, you know. Uh, so yeah. Yeah, it is that kernel, because now when the red was put onto that kernel, it just went all crazy. Yeah. Yeah, I guess we also should make a UI, like my last implementation edit UI, so that you can like play around with the values, so that I think it's actually H, honestly. But the honest truth is that like Lenia itself, you kind of have to like play around with it to get any like decent results that don't die out immediately anyway. So it's not just like the 3D aspect of it. It is, you know, that's probably a part of it, but yeah. It's definitely going to help when I like make a UI that that can work in it. All right. I am gonna peace out, I think. I'm super tired. Um, today was neat. I mean, I got all of it done. I mean, this is basically all that is inside of Linea here. I mean, it's literally everything. I think we may just have to. I may just have to make my own, take my own liberties with the equations and the math myself. So that's going to be my next attempts. Wait, are you doing some sort of image processing, or kernel convolution has some other meaning? So it is similar to what happens in image processing, but I have a kernel and I push it through a field of data, which instead of pixels is a grid of data that you can see here. Except in my case, it's a three-dimensional field. So the equivalent of that is that we are literally kernel convolution. It's doing the same math as in the image processing sense, but it's used for a different purpose, which is making 3D graphics in this case. Yeah, I need to make a UI, I guess just have a menu on the side so that we can move around the parameters, the growth stuff, and this and that. Do all of that. We also have some other things that we can implement that we didn't do yet. We skipped over asymptotic Linea, or well, we didn't skip over it. It's kind of the next thing is soft clip and that sort of thing. I have to look at the soft clip thing. What's the math behind soft clip? I forget. The soft clip is the formula is, yeah, so it's this. So I can implement this real quick. That's an easy one for me to do. It's this formula that it's for certain channels. We can set it to have different formulas for clamping the values. So I'm just literally copying my own code here. So this is 1 over 1 plus exp minus 4 times 1 minus 0.5. Okay, so that's the formula. And this would be applied when we're doing the update here. Instead of clamping, we would basically just would have this per channel as a as an argument, basically. So it would be instead soft clip, and I can't remember. So what else is going in here? Min and max. So it's the exact same thing. So this is what it's like with soft clipping. Really? Really, it just doesn't. Oh, wait a second. No. Wait, is it? Maybe I wrote the. No, yeah, that is definitely correct. Did I transcribe the function wrong? Ah, that's not 1, that's an I. Oh, yeah. Okay. Yeah, it's pretty cool. And then we can have asymptotic update as well, which is, this is also very simple. It's literally just kind of a one-line thing here. It is the the thing is, I have this growth thing inside of a lookup table in my other old code base, so I have to figure out how to move that over. I feel like it would probably be something like the bell of view. Is it this minus the grid? Be that minus the cell of the C1. No, it's outside of the parentheses. So it would be here. It would be here. This. We would have to take in the. Oh wait, no. So cells. Kernel C1. Yeah, minus that value. That would be the asymptotic thing. What? Oh, shut up. Oh, I don't actually put the I here. Okay, and that's very simple. That's what asymptotic math is. You're just basically subtracting the current value from the growth value. And yeah, you just basically have those variables per Cloud how to code. Yeah, well, he's sure as hell not getting my data. Hey, what's up, Fire Emblem? How am I running XP? I have it on my machine. It's not dual booted, it's just my other computer. I have a capture card into this computer. How did I learn all these math? I just did a bunch of projects with this stuff, like my first Lenia implementation, when I did the Lenia stuff, was I had to learn all the math, and so I started reading some of that stuff, when I had to do my first Lenia implementation, and then when I had to do my game engine, and then when I had to do my chess engine and all that, you just start to pick the math up along the way. Yeah, it's a legit XP machine. It's my old computer that I got out of the garage, Yeah, so that's that. So we have asymptotic update as well. So I think that's per kernel though, on the asymptotic update, or is it per channel? I forget. I think it is per channel. Yeah. So they do it per channel. So this would be if C1 has it. Yeah, that might be kind of a pain of a refactor, because now I have to. Could I still do all my work in an XP virtual machine or dual boot? There's some stuff that must be done natively. I'm not entirely sure. I'm sure you could do a few things. I think development from a virtual machine would kind of suck, though. Like, I mean, maybe it'll work. I have no clue. I really have no clue. I would assume that it would be kind of difficult, though. I mean, it's hard enough for me to plug in my peripherals. In fact, I can't use my mechanical keyboard inside of Windows XP because it does not enumerate it enough properly. So I have to program a driver one of these days. Maybe I'll do that on stream, actually. I have to program a driver so that I can do it. But, yeah. So this, it's not per kernel, it's per channel. Two ways we could do it. We could have a struct that just has our settings for each channel. I think that's what I'm probably gonna do. That website flashed your eyes? Oh, what website? Did I do something bad? Am I? Okay, I am. I was worried for a second that I was not. That I was streaming my other monitor. So let's just have it as channel data. Maybe we'll change it later to be the other thing, but whatever. So let's just call it. Let's do bool asymptotic. Bool soft clip. That's it. And so we'll initialize this channel data. We'll just have it externed. Yeah, we're gonna have a lot of fun cleaning this up later. Okay, so we have that and that. And now we want to just like set up, when we set up, we want to set up our channel data. Wait, we already have ch dot. Wait, hold on a second. We need to have that as to max channels. And that means that we have to have it underneath here. And this is also max channels. Okay, and now could not understand expression. Can you understand this? Fist in your face, dummy? What are you talking about? Channel data, like, why is IntelliSense being a jerk? Oh, my bad. Yeah, it's because I externed it before I define it. Yeah, that'll do it. That'll do it. Okay, so ch. And now we can define it per channel, right? And this is also going to be like what's in the UI later. That's what was in my old UI, was that you had like all these buttons that just like could toggle if it's asymptotic or whatever. And so now we're just going to say if we have to take in the oh no, we don't. See, no, yeah, it's kernel C1 is completely fine. Kernel C1 will always be the same. I'm doing great. Hey, what's up, Hassan? I am doing fantastic. So if it's asymptotic, then we do this. Right, then we do the asymptotic. And you're watching me from? I'm sorry, I don't know the flag. I can't get the flag. Is this Turkey? I'm sorry. I feel bad. I don't know the flag. It's great, man. I love when, you know, people from all over the world kind of watch. It's kind of like surreal to me that that happens that way. Turkey, yeah. Glad that I know that. chc dot soft clip, yeah. Okay, and then this is the option for soft clipping. Oh yeah, you're from Turkey too. I've gotten quite a few people from Turkey. It's actually like a lot, yeah. I wonder why that is, but I hear about like the internet there is crazy, right? With like that they don't allow you to like do stuff in Turkey with when it comes to like certain websites or like Discord or whatever. I don't know. That's what I heard. Did I spell this wrong? I think I spelled it wrong. Okay, I think it has a P in it. 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 Wait. Oh, it's the P is here. The P is here. Oh, okay. Okay. Okay, there we go. What's this dude making? I'm making, you know, 3D cellular life, hopefully. It kind of looks like, you know, a block of Swiss cheese right now. Swiss cheese. Man, I am hungry. I am. Anyway, so some layers have asymptotic and soft clip and some don't, yeah. Was this guy in the TCCPP server playing Minecraft? I was not. Unless, you know, I have like, you know, split personality or something. That would be crazy. That would be nutso. Be nutso for sure. Just playing DirectX? Yeah. DX9. Yeah. How does it feel like being a godlike being to these cells? It feels good. I have more control than I have, you know, over my own life. For sure. So that part does feel good. I kind of wish we could see inside, man. Like, you know what I mean? Like, we only can kind of see the exterior. It kind of looks like they're roses or like flowers because of the jagged edges on the outside. Yeah, I wonder if we can FFT it. That'll probably be what we do next. Maybe we are the cells. Yeah. Inception. Yeah, I mean, that might be the next thing, is like, can we FFT it? Is it possible to FFT it to make it a bit faster? But I also want to like just make sure that it can be pretty, you know, and not like look like this. Like, I definitely want to figure out a way to make it stable in terms of like us watching it like move around inside of the cube, and not just like, you know, that's how it's supposed to look, you know? It's kind of hard to get it in 3D space. As you can see here, it's pretty hard. But I'm trying. I'm trying. I am trying. I just want to go back. I think the way that we should go about this is just like literally do you know, one thing at a time. You know? Just give it a beta size of just one, right? Just one ring. And just try to get this looking not bad. Yeah, it dies immediately. Yeah. This is why it would be good to have like a UI or something. Is like, I used to just have it like a space bar. Actually, you know what? We could actually just do that. Yeah, why don't we do that? Let's do that. So when we have a message, when we take in a message, let's do space pushes us up. So instead, let's just do a different thing that we can just like, what should it be? Can I do Alt? Is that, let's do Tab. Let's do Tab, and we'll just do init Conway. Okay, so now if it dies out, we can press Tab and it makes a new one. Hopefully. Press Tab and it made a new one. Okay, there we go. So now it can't die out, which is good, because that's kind of been our problem all along, is the fact that it just dies out. But that's kind of how Lenia is, though. Is like, you kind of have to just like play with it until it doesn't die. It's like a petri dish sort of thing. Yeah, this one's dying out super fast. These are kind of the settings that they have as well. Like, it's not just me trying to make this stuff up from scratch. Like, for example, going back to the Orbium, which is the like original like starting point for Lenia, is, I believe, these settings. I believe it's actually 0.15 this. So it's actually this. But yeah, now it's not changing at all. What's the T for this, actually? The T is... one over T. I don't see, T is 10, so 1 over 10, so that's exactly what we have. And their radius is insane. Their R is 13, which is way too much. We cannot handle it at that much. I mean, we could just like sit here and then put it to 10 or whatever, and then like, you know, just wait. But yeah, it yeah, it's just every frame is going to take like a minute if we have a radius of 10. Like this. Which is why, I mean, fast Fourier transform would be pretty nice, huh? Yeah. 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 Probably the same effect would be just having a small kernel and then just reducing the field. Like if we reduce the like if we just do a 20 by 20, then we start to have a lot more updates. I think it's dying. Yeah. Hey, what's up, Crispy? How are you? Yeah. It did die there, like that was kind of a bummer. Yeah. Well, I didn't assume that this project was going to be easy. In fact, I have it in the description that this is not going to be easy. This is Windows XP. It is. It is indeed. It's my computer with Windows XP on it. Jeez, man. Yeah. Yeah, I wish that there was just like movement that we could get. There isn't really, like it's not moving. This is kind of the problem. Yeah. Yeah, it has only been 3 days, but yeah, I mean, the fact that it's just kind of annoying because I've implemented like everything that is inside of Lenia. I've implemented all of it, but it's still, you know, like, yeah. I didn't really expect to see the Orbium, you know, just like fly across the screen in 3D, but I you know, I did have some. Yeah, this is incredibly slow. The problem is our scaling on our kernels. like on the radius of our kernels is just so crazy. Like the radius on our kernels is the difference between like going incredibly fast, like this is incredibly fast in terms of like the speed, versus, you know, just like crawling at a snail's pace. That's kind of, so I mean that's fixed by fast Fourier transform, so that's probably what we should be doing next. But yeah, all right, well, honestly I made like you know, keep working on this tonight, because I definitely, it is crazy that we have like channels and all of this and stuff. It's like I feel like it's so close to like working. I just have to figure out some way to make it work, you know. It has to be possible. Yeah, I have to do some research if FFTW can transform in 3D, in 3 dimensions, because I'm assuming that it has to do that it's different than in 2D. I'd assume that. I may stream tomorrow. I may. I'm not really sure. It depends, like, if I have, like, if I know what I'm gonna do, you know? Like, right now, I don't really know what I'm gonna do. I'm probably just gonna mess around with it a lot. So, if I, like, figure out, okay, so I can start FFTing tomorrow, then I'm gonna do that. If I can't start FFTing tomorrow, then I may do some, like, you know, I typically, when I go live, is like when I know I can do something, you know, and then off stream I'll like spend time like doing like coding examples for the UI or etc. You know, like I'm not gonna really just like go ahead and learn all that live, but yeah. All right, it was a fun stream. Thanks everybody for watching. Feel free to join the Discord or whatever. I like seeing people talking there. It's pretty cool. I will see you guys soon. And yeah, you know, share your projects in the Discord, man, because it's sick. It's sick to see. It's always sick to see. All right, peace out.